Is my audio working this time? Discord's always doing some weird stuff, man. Actually, ooh, wait. This might be doubling. So let me switch this. There we go. Okay. That should fix it. Mikasa, what is that in Japanese? I don't speak Japanese. Alright, what's up? What's up, Mikasa?
It's not sorry. Yes, means hello. Konnichiwa.
Mikasa, do you speak Japanese? That's cool.
Not really.
I need to like
Not
need to figure out. I'm gonna figure out what you said to me. Luckily, we have Google Translate. What do we have? What's up, Grim? Haven't seen you in a while. What's up? What's going on, dog?
Oh god. My brother
God.
just told me, like, you said you missed me, so I just came back.
I do miss you, dude. I've missed you a lot, dude. Nala Coca. There you go. Oh, what's up? There we go. What's up? What's up, senor? Evening.
I've been working.
It is evening to you, right? Isn't it?
Yeah,
yeah.
It's 5:02.
Morning and good evening at all the wrong times on purpose to piss people off. So you know with me.
I don't
What's
even,
up? What's up, Destiny, dude?
I forget what evening means most of the time.
Dude, I went to bed at 6 o'clock last night. I fucked up. Like 6 a.m. So I know that was bad.
Like 6 a.m. or 6 in the afternoon?
No,
6 a.m.
6 in the morning. I meant to go to bed earlier, and then my buddy, ooh, you got a guitar. Nice, dude. Yeah,
I
I meant
fell asleep like at 1 and woke up at like 2.
Bro, it's because of the shit we've been doing.
Oh,
yeah,
God,
young God, dude, you need to go to bed at a regular. I need to go to bed at a regular hour. I was supposed to do things this morning. It didn't happen.
My parents are planning to either send me to rehab or something else.
Why are you going to rehab, dude? Please don't go to rehab.
I'll try not to.
Okay, good. Let's keep you out of rehab, dude. Yeah. Search us up, Jawbreaker Boy. What's going on here? Oh, Moog wants to come up and say hi. What's up, Moog?
He could just let himself out and just tell our friends that he's still going to
Oh, man. What's up, Jarbells? What up, Jarbells? Ian, where are you and Ramiro driving off to? Where are you guys going?
We're going to a homegirl's house.
Oh, homegirl's house. Okay, have fun.
It's an orgy.
That's dope.
You guys are too funny.
Oh no, not the red car.
Oh, that's a Genesis.
Oh my God! If you hit that hole, we're dead.
All right, Grim. I gotta start the stream. Good to hear from you though. I love you guys. Cool.
Okay, see ya.
All right, peace. Okay. What's up, everyone? Welcome to the Office Hours live stream. My name is Dr. Gold. This is Actual Education. This is a stream that helps you out with math homework, science homework, all sorts of fun stuff. I know a lot of you guys are new. We had, I think, over 165 new users this weekend.
That's dope.
What's a ton, dude? What, prostitute near knee? Wait, what's this? What do you guys, Jamarcus, what are you saying, dude? What, excuse me? What? Watch this when you're not busy. Okay, thank you. All right, cool. Yeah, so welcome. To everyone who's new, my name is Dr. Gold. This is Actual Education. We're a 501c3 nonprofit. We play video games, we give out prizes, and we help you guys out with math and science homework. You probably found us from TikTok. I know one of our videos there went kind of viral, probably on your, what is it, FYP for you page or something? Yeah, exactly. Yeah, TikTok. Yeah, a lot of people found us on TikTok. Totally cool. So little brief, like little backstory. We started this Discord, I think around 3 years ago, almost 3 years ago. We're on our 3-year anniversary coming up. As kind of a way to incentivize you guys to do well in school, help you guys out, as well as have a lot of fun, give out a bunch of prizes. This year, starting for this semester, we're going to be giving out a PS5 as our grand prize and a lot of other prizes. In previous years, we've given out tons of gift cards, controllers, headsets, keyboards. I'm sure everyone else can. We have a lot of people who have won things in this Discord. I think where do I have that? That's probably in. It's in what channel is it in? The prize group. Thank you, Teacup. Where do I have it? Like in the server guide or something? Here it is.
Yeah,
they
will link it.
Awesome, thank you. Yeah, so here, yeah, these are all prize. We've given out tons of stuff, Oculuses, I don't know, tons of stuff. Some people ask me like, is this real? Is this a scam? I'm like, no, it is real. Okay, so I hope everyone was able to register for the tournament. That's the first thing you need to do in order to get the role that allows you to really earn what are called MT coins in this tournament. So if you haven't done that yet, the website for that is register.actual.education. It's right here. And I can confirm the price is 100% real. This is not a pyramid scheme elaborately designed to feed on naive children. Yeah. Also, I'm curious. Like, what would I be feeding on you guys? Like, people like they're gonna take advantage of me. Like, how? I'm just giving you guys free stuff. What? But anyways, yeah. So here's the registration page. Once you filled this out, you will get the role, which is called, I think it's the Master's Tourney role. Let me pull it back up to here to Discord. Oh, why is it pulling that screen up? I don't need to pull that screen up. Okay. Anyways, okay. Yeah. And so once you have the role, then you'll be able to collect dailies, which is going to be what? Well, I need this to pick the right screen. One sec. Let me pull this out. This is, what's that? It's because it's popping out. One sec. There we go. Okay, there we go. That's what I want. Okay. Yes. Okay. This is the announcements channel. This is the only place you can do daily, and you do that by !daily. And if you haven't done it yet, it will give you a random amount of coins every day. This is a good thing that, so we have some people during the tournament have like 90, 100-day streaks on this. And as you build up more of a streak, it gives you more and more points. So this is a great way to get MT coins. Also, anytime we have special challenges or bonus rounds or bonus games coming up, they'll get announced in this channel. So that's why we have you do the daily in here. And then if you ever want to check the score, you can go to the scoreboard here and just hit richest. And that's going to show what the top 10 in the server are right now. So what we're doing for the first week, because I know a lot of you guys are new and you have like no clue how the server works, or you know you're not really used to, wait, what are channel points on Twitch? How do I buy these things and whatnot? So the first week is kind of like an orientation week where we're going to run the whole tournament as normal. But at the end of the week, we're going to do kind of like an in-between giveaway where I'm going to give out $100 worth of gift cards to the top 4 people. I think we're going to do top 8 qualify, and we're going to give out prizes to the first 4. So this is a way for you to figure out, okay, how do I earn MT coins in Discord? How do I buy these things on Twitch? And then at the end of the week, we'll reward, you know, whoever did the best. So you get a feel for how it works, and then everything will reset so that the next time we do the prize drawing, which will be for the PS5 and all the other big gift cards, that will be at the end of April. So that's why things are the way they are. Announcements are here. Good. Yeah, if you haven't read this, please read this wonderful, you know, series of rules and everything that I wrote up. This should answer most of your questions on how to get coins and how we're going to do prize drawings, and then what we're doing every week. I'll announce like what the game is and what the tournament rules will be. And yeah, that's that. Okay, cool. Does anyone else have questions? So yeah, I'll take a minute for like questions here, because there's always questions with this stuff. Let me see, and then I gotta put this up. It's like, you have a question? Aluju wants to speak. Okay. What's up? What's your question? What's your question, Moog? Is it a real question? That's always. I know you sometimes. Can we have an Moog channel? Chill. What do you want an Moog channel for, dog? What? Okay.
Can y'all hear me?
Yes. Yes.
Well, I have a question and stuff.
What's up, Aiju? What's up?
That I just was wondering if this server is mostly used to find people to play with, because I'm only trying to find people to play Call of Duty, I guess.
Oh yeah, no, totally. Yeah, if you're looking for other people to play games with, like for instance Fortnite Warzone, this is definitely the server to do that. I do Warzone like occasionally. I got kind of like upset with Warzone 3. Honestly, they really like screwed the game up. I enjoyed like Warzone 1 and Warzone 2, and then Warzone 3 just made things fucking awful. But
Well, to be honest with me, Warzone 3 is mostly what actually got better because in Warzone 2, knowing that they took away slide canceling,
yes,
I dropped bombs. Now that slide canceling is back and knowing how much weapons that I actually love came back, I'm mostly excited for the rest of to come.
yeah,
For Modern Warfare 2, we showing Walking Dead so-called is gonna come game or whatever. And I'm excited for that too. But knowing how people feel about Modern Warfare 3 and the campaign and all that, I really don't think it's bad. People do say it's bad. I don't know about their idea, but in my opinion, it's pretty good of a game.
yeah, yeah. No, I feel you. Yeah. So yeah, if you're looking for people to play Warzone with, we have a whole channel which I think is called. It's called like the Computer Lab or something, and you can just if you for instance, if you put in there, you can ping me all the time. You can ping me and say like, hey, does anyone, Dr. Gold, do you want to play Warzone? And if I have time, I'll ping the whole Warzone gamers role and see if anybody else wants to join in. And in addition to that, during the tournament, some weeks we will switch the games for what people get prizes for. So for the first week here, it's going to be Fortnite. So on Saturday, and I'll announce the specific rules on Friday for this, but on Saturday, we're going to have probably, I think, Tilted Towers as our little mini competition. And that's a good way to like earn MT coins, and then if you place well, you get more coins for that as well. And then some other weeks we might do Warzone or Roblox or Valorant. I don't know. I mix up the games every week is what we do. Yeah.
Well, for Fortnite, I play. The thing is that I don't really try hard on that. I could invite my brother one of these in one of the tournaments because he may be younger than me, but believe me in this, he is, how do I say this, experienced as hell on the Fortnite.
He's goated. He's goated at it.
That's dope.
Like, he takes his game a little bit.
Yeah, there are some very sweaty Fortnite players in this server, like Shaq, and Ethan's pretty good too.
When my brother is playing and all that, when he tries to do call outs, he screams them out, like yells. So
Yeah.
anytime I'm playing with him, it's just stressful because he's yelling in your ear, telling you, "There's an enemy, go get him, push him."
Yeah. That's called being good on comms. Good on comms, is what we say.
Yes, the thing is that he pressures you to do things that you're trying to think, but he just tells you and keeps going and keeps going. That's the reason he prefers playing solos. And when he does and loses, when he's so close to winning, he cries. And
Oh no, dude!
yells.
He gets hella emotional about it, dude. He gets hella emotional. Okay, cool. All right, so AJ, I hope that answers your question and stuff. I gotta start more things with the stream here, but yeah, if you ever have questions about how things work and whatnot, I posted the link to register. Do that so that you get the role, and then you can start doing the dailies to get credit in the server. Which I'll get. It's not instantaneous. Do it, and I'll do it at some point tonight. But yes, we don't need an NSFW channel. Y'all chill.
Yeah, well, I think you need to come back, and yeah. Thanks for answering my question, and I guess I'll leave now.
Cool. Very good. You're very welcome, dude. Cool. All right. What's up, Ethan? You want to say something real quick before we start getting into questions?
Yeah, what's it called? I got my biophysics quiz from last week.
Cool, dude. How'd you do? How'd you do in physics?
I got an 8 out of 5.
85. Nice.
That's dope.
Not bad. I think you can get an A, but not bad.
Yeah, because I messed up a question. It was just that weight and stuff. It messed me up a bit.
Oh, okay. Join, dude. Dude, dude, Teacup, what's this? Join our communication server? What is this, dude? Community server is what it is. Yes, I love this text though here. Yeah, this is funny. Check my pins. What'd you pin? Check the pin message. Is this it? Okay, I like that. Yeah, cool. Okay, I appreciate that. Yeah, because some people ask if we're legit or not. All right. Cool. again, any other questions? Send me DMs. You can tag me wherever in the Discord. I will get to them. I promise at some point.
Actually, that's all.
What's up?
I have a question.
Yes.
Do you actually earn MT coins from asking office hours questions?
Good question.
Or
That's
not?
a very good question. Yes. So how we're changing that from last year, because I understand that not everyone can make every single stream, just because of time zones, or like you guys have a life, like I get it. So instead of being able to earn MT coins every time you earn a question on every stream, I'm doing it so you can only do that once per week. You can ask as many questions as you want throughout the week, but you will only get MT coin credit for once per week. So for instance, Ethan, you can ask a question today. If we go over it, you get the 2,000, and then you get like the weekly credit. If you ask a question on Tuesday, you don't get that 2,000 again, but you will get the bond coins, so that's okay. You can always get that. Some of the students
What's
are
the
also
weekly thing?
well, so that's just to make it so think about if you've ever played, for instance, yeah, Fortnite has this. Don't they have like weekly challenges or something, right? Like contracts, like do this in a week or do this in a week, and you get like an XP bonus or something.
Oh, yeah, you do that. You have that.
Yeah, it's kind of like that. So every week there's a contract of, if you ask a question on the stream and we go over it, you get the XP for that. But you can only get the credit for that once per week. And then it's the same thing for the games on the weekend. So we're gonna have games on on Saturday and Sunday, but you only need to show up to at least one of them to get the participation credit for that. You can still get the winning credit if you show up to both, but to get that participation credit, you just need to come to either Saturday's game or Sunday's game. Yeah. I'm not no, you were what? I can't win. No, yeah, you'll chill. Yeah, most games have that feature. Yeah, so a lot of what we do here, and this is why we do what is called like gamified learning, which is we take learning but turn it into a video game. And so we have a lot of the same mechanics where there's weekly contracts, there's rewards for doing this, daily check-ins. Also, there will be nerfs. Like I will start adjusting points on things if I see that something's becoming too OP. We just want to make it fair and make it fun and competitive. So yeah, exactly. I kind of like this because I don't have questions, so I would have to ask anything. Well, you should ask at least one question at some point during the week to get the 2,000, and I may bump that value up if I see people aren't jumping on it quick enough. So, yeah.
Well, I'll definitely join.
You do. No, and I appreciate your question. So yeah, here let me show an example of how this works, right? So in the Discord there's a channel called Help Screenshots, which some of you have found, which is great. And what you do is you post a screenshot of one of your homework questions that you're going over in your real life IRL school. It can be something that you already know, it can be something that you need help with. Doesn't matter. I'll find a way to teach you something from it. And also other people on the stream learn when we go through it. So here's an example of Ethan is really good at asking questions all the time. So yeah, and here's the channel if you guys are looking for it. It's called Help Screenshots. It's right here. And so you can't post any text in this channel. You can only post screenshots. So a lot of the students here have done they know the score. They already know the rules how to do this. But for y'all that are new, this is what you do. Great. This is a other good example here. Yeah. Awesome. Okay. Such as Darky Mug. Don't call him Darky. Okay, what's up, Izetsu? Cool.
That just reminded me of something.
What's up?
Someone in my class used to call me by the S word. Shitty.
Oh, shitty? Oh, that's not nice. Don't have people
Yes.
call you shitty.
Did you want to know what I said? You want to know what I said?
Yeah. What'd you
You
say?
want to know what I said? Well, then, nice job, Blackie.
Oh, don't say that, dude. Don't say Blackie to people, please. Yeah, that's.
But I had
that-
to.
It's okay. I know you're black, so it's fine. But okay. But okay. Let's go. All right. Are we gonna start the stream? Yeah, the stream is starting. Let's do it. We got questions today. All right. Ethan's asking about torque. This is a good physics question here. So he says, here's a uniform meter, 2 newtons resting on a fulcrum. Do you know what a fulcrum is, Ethan?
Oh, actually, hold on. My teacher just gave me something like that today. Hold on, let me try to find it.
Okay. Monkey's asking, how does Dark have 10K? Okay, so last week, before we had all the new students coming in, you probably saw that that we were selling raffle tickets, right? I was doing that to try to get people who already had a bunch of channel points saved up from Twitch to spend them before we started the tournament to make things fair, but still give them a reward. So I decided to roll that into the orientation week. So if you bought raffle tickets with your channel points last week, those got converted 1-to-1 to MT coins. If you still have a bunch of channel points you're sitting on because you've been watching the stream for weeks and weeks on end, spend them this week because that will give you the best chance at winning the giveaway spinner thing we'll do on Monday. There's a bunch of gift cards there. That's where that goes. There you go. There's Sam. Yeah, good. Awesome. See? Good job, Sam. Sam just went all in. Oh my God, Sam. How much are you redeeming? Holy shit. Yes, this is a good example of, yeah, there you go. He says I got 41K left. Okay. All right. Yeah. Oh, man. Yeah, exactly. So that's why we have this, by the way. That's why this is orientation week, is because there are some people, such as Sam, who have been loyal viewers and been watching this Discord and this Twitch stream for years, and they have a big, like, war chest of these channel points saved up. So I want to get them to spend them, but also give them a reward for it. So that's why we're doing this. There you go. Cool.
All right. So is a fulcrum like a pivoting point?
Good. A fulcrum is called the pivot. Yeah. So that's for instance, everything here like rotates around what's called like the fulcrum. That's this thing. You know, you can kind of think of, I don't know if you guys still play outside or some shit, but like you can have like a seesaw, right? When there's like some person here, right? I don't know. Maybe they have legs. This would be called like the fulcrum, is what it is, where they go like back and forth. Yeah. Nick, yeah, everything does reset this week, but yeah, I want you to dump coins this week, because if I see you dumping them during the tournament, I may put restrictions on them. There are no restrictions for this week. You can dump as much as you want this week. That's okay. But yeah, then everything will reset, so everyone's on a level playing field next week. Yeah, okay. All right. Calculate the weight X. Okay. Oh, and this is a spring? Okay. Which is providing 5 newtons. All right, cool. Okay. Bum.
I wonder how you actually do this. There's like 2 methods that you use apparently.
What are the methods you know?
Well, I don't know if they're really called methods, but they're like, what do you say?
Strategies? Ways of doing it?
It's
Attack
like,
methods?
Equilibriums. It's equilibriums.
Sam just dumping so many coins. Oh my God, Sam. Yes. So there's what's called equilibrium means things are just not moving. That's what equilibrium means. Okay.
Yeah. There's transitional equilibrium and rotational equilibrium.
Yeah, I mean the fancy word for that is there's like up down equilibrium, so things not moving up and down a certain amount, and then there's rotational, which is rotating. Okay. Wow. Sam, I'm gonna have a fun time adding up all your coins. Yeah, it's probably a lot. Okay. So let's do the rotational equilibrium. So here's actually a good point. So if you have, for instance, Ethan, this ruler here, okay? Which direction is, for instance, this force going to cause it to rotate? If the force is applied here, is it going to rotate this way or is it going to rotate this way?
It's not going to rotate in any way if it to the right.
Well, it's going to try to rotate to the right? Ignore this. Say we don't even look at what these forces are. Let's just say we just have this force, right?
All right.
This is going to That's going to cause torque to the right, okay? Do you know how to calculate what torque is?
Why is it gonna cause it to the right? Because it's already.
Well,
on the
it's gonna cause it to rotate. What we say is like clockwise. Sorry.
Oh wait, it's on the left side, and when you're moving left, it's kind of like anti-clockwise.
Well, no. If it's on the left, but I'm pulling up, just think about it, Ethan. Like, think about if I had this, right? If I take this and I pull it up, right? Which way does this thing rotate?
To the right, yes.
It rotates clockwise, is what we say. Okay, it does that, right? Okay.
Oh yes, clockwise, yes.
Cool.
It's
All
still
right.
the same thing.
Okay. Good. Okay. Clockwise.
You were asking me about torque?
Yeah, it's torque, just torque. It's not torque. It's torque. I know in Spanish K, this looks like torque, but no, it's just torque. I mean, it's spelled like this, torque. Or it's pronounced like that. Okay.
All right,
Okay.
so I got it. Let me. You asked for the formula.
Yeah, what's the formula?
Okay, I don't even know if this is correct, but I searched this up on the internet, and it says like the torque is equal to the radius times the force times the sine of the angle.
Yep, good.
Is that really
Um,
correct?
It is correct. But what it means is that the torque is going to be equal to where the force is that's being applied times how far away it is from the pivot point. Okay?
You show me.
Yeah, I'm going to show you right here. So, okay. So let's for instance, let's look at the torque from this spring, okay? What's the amount of force that's being applied?
5 newtons.
5 newtons. Good. Okay. And what we said it was FD, and I think this is cosine theta, right? Yeah. Okay.
Yeah.
So
No,
in
no,
this
no,
case,
it's sine theta. Sine.
is it sine theta? Yeah, you're right. It is sine theta. Wait. Yeah, it is. It is. Sorry, because it's a cross product. Yeah. Okay. Yes. 5. Okay. How far away? What distance? How far away is this force being applied from the fulcrum, from the
100.
pivot point?
Oh,
It's
wait,
not.
80,
No,
80.
it's not 100. Yeah, it's 80. Right? Because if this is 0 and this is 80, right? This distance here is 80. Okay. You got to put everything in meters. So this is
Yeah.
0.8. Okay. And then sine of theta, that refers to the angle between the force that's being applied and basically the direction to the pivot point. Which all of these forces,
90.
this one's 90. Yes. Do you see how these are all 90 degrees? Right. This is technically called like R hat is what they call it, but don't worry about that. Okay. Right. And do you know what the sine of 90 degrees is? It's a good one to know.
0.5.
No. Sine of 90 is 1. 1. Mikasa knows that, right? I know you know
Oh,
that,
okay.
Mikasa. Yeah. Good. Okay. So, this is
Let's
going
go.
to... Yeah, let's go. Yeah. we know our unit circle. We love it. Okay. Cool.
Wait, hold on, Dr. Go.
What's up?
I took this on an online calculator. It says that the sine of 90 is 0.89.
Well, that's probably because you did
You're
it in radians, right, Mikasa?
Yeah, you're in radians.
Yeah, you're in radians.
Yens. What?
Yeah.
Don't do that in exam.
Yeah. Yeah, that's... I.
You
You know- Okay, have you seen this though, bro? I've seen protractors which apparently measure stuff in radians. Like it is kind of a good it is kind of like a funny thing of how we teach everything in degrees because then it screws everyone up once we like have to start doing trig
Yeah.
functions and stuff. What was it? I think it was Amazon protractor. I think Noise showed me this, dude. Yeah, I was like what?
That's crazy.
Yeah, look at this. They have a protractor which doesn't do degrees. It does it in radians. That's fucking goofy,
Start
dude.
using that more.
Yeah, that would be so goofy, dude. Oh man. Yeah, no, it's not degrees. Yeah, y'all are used to the regular protractor, which has like 5 degrees, 10 degrees. Yeah. Okay. Yeah, Ethan, this is why you gotta be careful. So here, if we look on the calculator, real quick, let me pull the calculator up. Where are you? Calculator. There we go. So if I do the sine of 90 here, and I'm in degree mode, the sine of 90 degrees is 1. But if I do the sine of 90 radians, so if this is in radian mode, this is going to get you the 0.89. This is the difference. Okay?
Okay, I see that. But they still kind of equal to 1.
Yes. Well, yeah.
So I don't see a difference.
Well, no, 0.8 is not 1, right? This is not 1. This is 0.89. This is a different number.
But if you round it off, then yes.
Yeah, but not rounding. Do you see how sine of 90 degrees when it's degrees is exactly 1? That's the point you want to make. Yeah. So make sure if you're using degrees you put things in degree mode. Okay? All right. So this gives you a torque of 5 times 0.8 times 1, which is just equal to 4, okay? And the units for this are newtons dot meters is what they are. Okay? Now, more importantly, okay, this is what I wrote here, okay? If something causes it to move clockwise, that is a negative torque. If it causes it to move counterclockwise, that is a positive torque. It's a weird thing. I don't know why they do this in physics, why it's positive and negative. I think it has to do with like just how a cross product works, right? It's like R cross F has to curl one way.
It's like contradictory. It's like
Well, yeah,
contradictory
it's kind of weird. But yeah, so clockwise is negative, counterclockwise is, which actually does make sense if you think back to whenever you measure angles, for instance, right? Right, this is like 30 degrees, right? If I want to go up an angle, like let's say I want to go to like 45 degrees, do you see how you move counterclockwise? Like for instance, this would be, I don't know, 120 degrees. Do you see like as the number goes up, the angle moves counterclockwise? It's kind of a weird thing.
Yeah.
Because I mean,
Weird, yeah.
I think about clocks. Clocks just go clockwise. Can you imagine if we had counterclockwise clocks? That'd be almost as goofy as the radian protractor. Okay, cool. So this is negative, Ethan. All right, this is a negative torque. Cool.
All right.
All right. And then we need to calculate the other torques, right? So you have this is the 2 newtons, right? Okay. Let's calculate this torque. So what's the torque due to this force then? The green one, the 2 newtons. This is technically the weight of the whole meter stick is what it is. That's what it is. So what's the force?
Oh, 2 newtons.
2. What's the distance?
I guess 30.
Good, 30. Yeah, cause see, this is 0.3 between 50 and 80. Good. Okay. Okay. And then again, sine of 90 degrees because this is still 90 degrees, right? That's just still gonna be 1.
That's dope.
Good. So this gives me 0.6 Newton meters. Okay. And then I want to ask you, Ethan, okay, is this torque gonna be positive or negative?
We're going on the right.
Well, we're here, right? And the force is pulling it down. It's pulling it down. Right? Is that clockwise or counterclockwise?
Counterclockwise?
Counterclockwise, right?
Mhm.
Does the triple slit experiment exist, Jamarcus? Yes, and counterclockwise, remember, is positive, okay? So this is going to be a positive torque, all right? Now, the last torque we have to calculate, so we don't calculate the torque of this one. Do you know why we don't?
What? Which one?
Of the R here, this one. This is technically called the reaction force. It's the force of the fulcrum on the thing. Do you know why we
Why
don't?
don't we calculate it?
Okay, so let's look at what the equation is, right? So there's a force, which we don't know. What's the distance of this from the fulcrum?
I don't know.
It's 0. Do you see how this applies exactly where it is, right? This one applied 30 centimeters away, right? This one applied 80 centimeters away. This one gets applied 0 centimeters away. So when you put in... because it's right on top of the pivot point. Yeah. What's up, lady? Yo, Sensation Black, another $6.40. Thank you, dude. You're our #1 donor, dude. I have to make an animation for you for that. Yeah, I'm gonna do that. Sorry, I had so many things I was doing this weekend, getting the tournament ready. Okay. Ethan, so this force gets applied at the pivot point, which means the distance from the pivot point is 0. Okay?
Alright.
Are you... Server... Okay. Alright, so the last one is this, right? This weight here, okay? Right? Which has some force on it. So let's... Here, I'll make this one. This one's green. This one's red. And then let's make this one pink, okay? So the torque of the pink one is equal to... Do we know what the force is of this one? Oh, your eyes, okay. Oh, okay. Oh, okay, don't. Yes. Ethan.
Yeah?
Do we know what the force
I'm
is here?
here.
Do we know what the force is here?
2?
No. We don't. We just know it's X. This one was 2. We don't know what this one is. Okay? So that force is X. And then what's the distance? How far is this one from the pivot point?
Okay, 60.
60. Good. So that's 0.6. And then again, just put the 1.
And isn't that just 90?
Right? Sine of 90 is just 1. Okay. So this is going to be 0.6x Newton meters. And then, good question, is this going to be a positive torque or a negative torque?
Positive?
Good. Because it goes right, it's going clockwise. Okay, positive. All right. Last bit here. Okay.
You do counterclockwise.
No, that... sorry, counterclockwise. Counterclockwise is positive. Sorry.
Show me again how?
So here, Ethan, right? Force is pulling it down. That's counterclockwise. You see that?
Alright.
Okay. All right.
Oh, wait, this is clockwise. That's clockwise.
No, that's counterclockwise.
Oh, okay.
Clockwise
Yeah.
is... Yeah, okay.
Yes.
It's confusing, bro. I get it fucked up all the time. Dude. Okay. Last bit, we're done. Is that at equilibrium, the sum of all the torques has to be equal to 0. Okay? So adding up all the individual torques has to go to 0. Which, let's see which ones we have, right? I have -4 from here. I have plus 0.6 from here. And then I have plus 0.6 times x from here. And this all has to equal 0. Do you see how we can solve for what the weight is, what the force is on this pink one here?
I think so.
Okay, how do we do it?
I think you... Hold on. Don't you add the 0.6s since they're both the same?
No. These notice how this has an x on it and this one does not. So you can't add those together.
Oh, okay.
Okay.
Oh, wait, but...
You can add
But
these.
-4 and 0.6, yeah.
Nice.
Or
Yes, you can add those. Yeah.
this will give you 2.4. 2.4,
Negative
right?
negative 3.4. So plus 0.6x is equal to 0. Next step, what do we do?
And divide 0.6 on both sides.
No. You don't want to divide. Well, we could, but that's kind of weird. I would move this over first.
Why?
It just makes things nicer. I don't know. I mean, I guess you could.
No, I mean,
The problem is, like,
I
you gotta
mean, like,
divide this by
divide-
0.6, you gotta divide this by 0.6, and you gotta divide this by 0.6. What you're doing is technically not wrong. It's just kind of weird. It's, like, strange. Like, I don't know. I prefer, so, and this is a good, again, for everyone watching, I'm sure you have to do algebra at some point, and this helps as, like, an algebra trick. Whenever you're solving for a certain variable, which in this case is x, you want to look at what number is the furthest away from it, which in this case is this. See what operation is happening. In this case, it's being minused. And then do the opposite of that. Okay? So what's the opposite of minusing 3.4?
or subtracting it, it's just adding.
Yes. So I'm going to add 3.4 to both sides. Okay? Because now this goes away. And you're left with 0.6 times x is equal to 3.4. All right? Again.
Now you can divide.
Gus, yes. Now we can divide, because this is the thing we're looking for. This is the next closest number to it. So now we're just going to divide by 0.6. Exactly. Yeah, good. Divide by 0.6. Divide by 0.6. And you're going to get that x is equal to, and let's pull the calculator up, 3.4 divided by 0.6. That's going to give you 5.67 newtons. Good job.
That's dope.
So that's cool. Also, one last thing.
What's up, dude?
What's the answer for that one again?
5.67 newtons.
But what about W? Is it just 0?
No. The weight is that. The weight is 5.67 newtons. Weight is technically measured in newtons. Is what it is. Yeah. Okay.
Both of which are 5.67?
What do you mean? What do you mean? Yeah, X is the weight.
Both answers.
Oh, you mean part B? We'll do part B another time. No, it's okay. Wait, why is my...
Okay.
What the fuck is up with the bot now? God damn it. There we go. Okay, now added correctly. Okay, cool. So, Ethan, there you go. So, you get a bond coin for asking a question, going through it. You also get 2,000 for 2,000 MT coins for asking a question. So, here we go. And then what I'm going to do is I'm going to give you the role of, I think it's like weekly question. So, there you go. So, now you have the weekly question role. So, now you know whether you asked a question this week and got credit. Cool?
Alright.
Okay.
Yes.
Nice. Okay, let's get
Hey,
Taco Cat. What's
what
up?
color is
What's up?
what color is the role of the weekly question?
Oh, it's just
Just
gray.
gray?
It's gray. It doesn't replace anything. Yeah, it's okay.
Alright.
Taco Cat, you're next. What's up? Monkey, Taco Cat. You have a bunch of names on my server. Which one do you want me to call you, Taco Cat? Do you want to be Taco? You want to be called Taco Cat or Monkey? I'm confused. He says lol. Yeah, which one? Taco Cat. Okay. Yeah, okay, great. Okay. Okay, cool. You said I want to learn how to do exponential functions. Okay, exponential functions are cool. This is an example of an exponential function. Exponential function is it's a graph that looks something like this. It'll be y is equal to a to the x. So where a could be just like some number. I'm sure you guys remember from probably early algebra and stuff, like y is equal to mx plus b. This is the equation of a line. Okay? This is what they call technically a linear function. The reason why it's called a linear function, linear, right? We know lines are straight. So, you know, that's an example of a linear function. Okay, that's what this would be. This is an exponential function, which means it's all sorts of curvy, which looks, you know, kind of weird, right? A lot of things in life are linear functions. Isn't like compound interest an exponential? Sorry, a lot of things are exponential functions. Like compound interest, I think, is an exponential function. That's why credit cards like screw you up. Stocks can be exponential functions. Yeah, depending on the stock. They can go both ways, right? You could have an exponentially down function, right? If it's, you know, Enron when they were getting caught for fraud. Or it can be like GameStop when everyone was pumping the shit out of that stock. Yeah, that was also exponential. Right? Okay. Okay. So, Taco Cat, how this works. So, the couple questions they can ask you about exponential functions. One could be how to graph it. Do you know how to graph something like this? Do you know how to graph, for instance, like y is equal to 2 to the x? It's kind of a cool strategy for doing this. No? Okay. The easiest way to graph something, if you don't know, you know, exactly what it looks like or what the family of functions looks like, is to create some sort of table where we're just going to put x points and y points, okay? And we're going to plug things in to see what it would look like. So, for instance, let me just pick x is equal to 1, okay? If I put 1 in for x, what do I get out for y, Taco? So it's an exponent. It is. It is an exponent, yes. Yes, good. Yeah, 2 to the 1, right, which is just equal to 2. Okay, great. What if I put x is equal to 2? What would I get then for y? Four.
Nice.
Good. 4. Yes, good. All right. Here, I'm going to have 2 other ones that might be a little tricky. What about if I put 0? Do you know what happens if I put 0 in? Could get a little weird. 1. Yes. This is an important thing. Anytime you have any number to the 0, as long as that number's not 0, that's going to be equal to 1. Anything to the 0 power is 1. 3 to the 0, that equals 1. You know? 69, 420 to the 0.
Nice.
That equals 1.
That's dope.
So, anything to the 0 is 1. This is also going to be 1. All right? And last little, maybe a little bit trickier here. Yeah, it's a weird number. Yeah. What about if it was -1? What if I have 2 to the -1? Do you know what happens here? One half. Yeah, very good, very good. Yeah. So this is another thing that sometimes people get wrong. But anytime you have something to a negative exponent, it means you invert this. You do what's called the reciprocal, and then you make this exponent positive. So in this case, this becomes the reciprocal of 2 is like the reciprocal of 2/1, and that's going to be 1/2. And then it's to the first. So, for instance, if we had like 6/5 to the -2, this would end up becoming 5/6 to the +2. You flip this is what you do. Yeah. Okay, cool. All right, good. So you know this is 1/2. All right, so now look what happens here, Taco. Now you can just graph the points, right? When x is equal to 1, y is equal to 2. That's this point right here, right? When x is equal to 2, y is equal to 4. That's this point right here. When it's equal to 0, when x is 0, right? It's equal to 1. And then when x is -1, it needs to be 1/2. So 1/2, right, we can see is kind of in between here and here. It's like right there, right? So that's why that's this. There you go. That's how you can graph an exponential function. What is that? That beta thing? Yeah. And there you go. And that's how you do it. Nice. Good job, Taco. Dun. Taco Cat, good. Let's give you coins. 2,000, and then I need to give you the roll. I should make a command to actually just give this roll. Weekly question. Good. Sweet. Good job, Taco. Okay. Awesome. All right. Let's roll. Next question. Jamarcus. Radiative collapse of a classical atom. Okay. Jesus Christ. What? Okay. I'll try to do some of these. We got a lot of questions to go through today. All right. Which is good. I'm glad. You guys are picking up quickly like how this works. Okay. This looks like a physics question almost. It looks like maybe there's differential equations. Okay, suppose the world was governed by classical mechanics. In such a universe, we might try hydrogen. We know from that a non-relativistic accelerating. Okay, cool. Show that the energy lost per revolution is small compared to the orbit. Shamarcus, where the fuck did you get this question from, dog? God damn it, Jamarcus. You're in 7th grade. What are you doing asking me fucking electrodynamics, dude?
You found Oppenheimer's homework.
Yeah, dude, what? Oh, so you know the research thing? Is this the research thing? Is this part of your research class? They had me watch a lecture? Okay.
No way.
Oh my god. And then the homework. This was the homework they gave you? This was the homework? What? Okay, what? Okay, alright. Okay, one sec. Show that the energy loss per revolution. I get how this works. I'm going to do just part A for you. Is small compared to its kinetic. Okay, cool. All right. Okay. I got to teach you a little bit of calculus in order to do this. This is punching way above your weight for a 7th grader, but it's okay. What's going to happen here is I'm going to move this to the right so that we have DE is, and I'll explain what this all means. Is -2/3 q squared a squared over c cubed dt. Okay, here's what this says, Jamarcus. DE, which is the change in energy, is equal to some number times the change in time. Okay, so if this is a certain amount of time that elapsed, let's say this is like 4 seconds for dt, this will tell me how much the energy changes. Okay, In this case, because there's a negative out front, we know that the energy is going to go down. Yeah. So this is showing that, again, dE, the change in energy, is going to be negative, which means, yes, it is losing energy. Now, what we have to do then, right, is integrate both sides. This is integrating dE, integrating dt, okay? And we're going to do that from, I'm going to say E0 to E final, which is going to go from T initial to T final. You have to set bounds. So bounds defines like what's the start and the stop. So here the energy starts at some initial energy. Sorry, let me call it EI. And it ends at some final energy, okay? Here this starts at some initial time and ends at some final time, okay? So when I integrate this, the integral of dE is just equal to E, but then that's evaluated, right, from A to B. So this becomes E at A minus E at B. Do we get this so far, Jamarcus? Do you get how this becomes this? Simple? Okay.
Not the way around.
Oh, do I have it wrong? Oh, yeah, yes, thank
Should
you.
it be E of E?
EB minus EA. Sorry, yeah, you're so right. You're so right. Thank you. I'm missing the fundamental theorem of calculus. Okay, cool. All right. So this is going to be EF minus EI, right? Which is basically the change in energy, okay? Is going to be equal to, this is nice because none of this has t's in it, right? So this is negative 2/3 q squared a squared over c to the third. And then that's going to be dt. So the integral of dt from t0, from ti, I keep using zeros and i's, to tf. This is going to become tf minus ti, which is just going to be equal to delta t. Okay. All right, cool. So now what we have to do is we have to figure out how much time elapses in order for it to do, where is it? In one revolution. The amount of energy it loses in one revolution, okay? So this becomes a, by placing that a non-relativistic electric charge. Okay. So that has to do this, I believe. So we have electric charge here, right? Okay. And it's moving around in a circle. And we got to figure out the amount of time it takes for it to do that. A is the magnitude of the acceleration. Oh, okay. I think, okay, this is actually not too bad. What the flip? Yeah, yeah, okay. Here's what's happening, Jamarcus. You have an electron here, right? That's moving around in a circle, okay? And they want to know how much energy does it give off when it does one revolution. So what I'm going to do is I'm going to try to figure out the amount of time it takes for it to do one revolution. All right? What we know... Oh, fuck. Is, okay, when something moves around in a circle, it has what's called like a centripetal acceleration towards the center. This is a physics thing. So in order for something to orbit, it has to have an acceleration towards the center, which is equal to AC. And this is going to be equal to mv squared over r. Or sorry, just v squared over r. Correct? Mikasa, you let me know if I'm making any mistakes here. I think I'm correct with this.
I think it's mv squared over r. I think you are right.
Well, that would be m times AC. I think just the acceleration term is just v squared over r. The centripetal force, the force that pulls it in towards the center, that's ma. Yeah, no, you're right. Yeah. I know that's the thing that, yeah, that's the thing that gets confused a lot. Okay, which they're giving me a here, which is nice. I think they say here they say with an acceleration a. Okay, so I already know this. So here's the cool thing, Jamarcus. If I know this is traveling at a velocity v, how do I figure out how much time it takes for it to go in one revolution? So let's think about like, so velocity is equal to distance over time, right? So let's think about that. The amount of distance it has to travel for one revolution, that's equal to 2 pi r. What's up, Woody? I'll get you in a second, Woody. Give me a second. 2 pi r, right? That's the distance for one revolution. And then this is going to be equal to the time for one revolution, which we're going to call big capital T here, right? The period. Period is the amount of time it takes for something to do an oscillation. Okay? So this velocity, right? This was v, is equal to 2 pi r over tau. Or big T, I guess. So I can now plug that in to here. Okay? And I get that A is equal to 4 pi squared r squared over t squared, right? And then that's divided by r, which is the same thing as just putting another r down here. So then this goes away. So this is 4 pi squared r over t squared. So then, t squared, if we move things around, is equal to 4 pi squared r over a. Does that make sense so far, Jamarcus? Let's see if he gets that. It does? Okay, cool. So now, remember, this delta t, this is for one revolution, which is equal to this, okay? So if I plug this in this case, this is 2 pi square root of r over the square root of a, okay? And we throw it into here. I'm going to get that delta E is equal to negative 2/3 q squared c cubed a squared. And then there's another 2 pi square root of r over square root of a. Oh, and did they give us r? Huh. Well, they don't give us r. That's bad. I feel like I need r. Okay.
When we were working out the distance, did you have to write 2 pi r, or could it just be 2 pi?
No, because I need a distance. I need like a physical distance, right? Because this velocity is in like meters per second. So this has to be in meters.
Oh, right, yeah. That's
Yeah,
great.
right? Yeah. I think what's going to happen, because they want to compare it to the electron's kinetic energy, right?
Yeah.
So, okay, so this is delta E. Okay. Sorry, delta E. But then the kinetic energy, right, of an electron, that's going to be equal to 1/2 mv squared, which, again, I don't have the mass either, right? Yeah, Q would be -1. Or not -1. Q would be negative E, is what we say. Yeah, Q isn't 1. Hey, yeah, notice they put things in CGS. Remember I was talking about how, like, this is centimeters, grams, seconds, instead of meters, kilograms? Yeah. Interesting. Okay. Well, I think you have to show that this is small compared to this, which... Let's see. Oh, remember, we did say that this was V, right? We said that this was V, right? So, this is equal to 1/2 m, and then it's 4 pi squared r squared over t squared.
The
So they
question
want-
on everyone's lips is, why is coulombs Q?
It's charge. Q is just charge. But then coulombs ends up
I just
being...
mean, why is it not C?
Oh, because C is the speed of light. C is always
Oh,
the
yeah,
speed
yeah,
of
of
light.
course it is.
Yeah, we can't. We can't.
C then.
Yeah, big C. Okay, so this is your answer, Jamarcus. It's this compared to this. One sec. Wait. Oh, we could just leave this as... Sorry. We can just leave this. Here, let's just leave this. Let's just leave this as T, right? The problem is
What's this for?
this is for one of Jamarcus's research classes or something. The problem is we still have an R, right, versus this. One sec. Let me see if there's... Because I know this is done in LaTeX, and then I see that there's this. I guarantee this is out of like some Jackson homework or something. Which, by the way, Jackson is like an absolute like bane of the existence for graduate school kids. One second, let me pull it out. Show the energy lost per revolution is small to the electrons' kinetic energy. Yeah, here we go. Got it. Got the question. Let's see how they do it. Oh my god, there's so many pages to this. This is just part A? Oh, okay. Okay. Yeah, no. I see this. It's not bad. We were on the right path. But wait, where are they getting that mass from, though? Ooh. They do it by the Coulomb force? Dude, what? Okay. All right, this is cheating though. This is kind of cheating. Oh man. You have an answer key? Yeah, it's okay. I see how this is working. So they kind of cheated with this. All right. They said, this kind of goes back to what we were talking about forces, right? So the force of an electron orbiting something else, okay, there has to be like a positive thing here, right? That force is going to be related to q squared over r squared. And I think in CGS, do you assume k is 1? Yeah. Is k 1 in CGS? Is that right? K q squared.
If I knew what CGS was, I could ask you.
Yeah, okay. Yeah. Okay. This comes from Coulomb force is usually this. Is equal to 1 over 4 pi epsilon naught, and then it's Q1, Q2 over R squared, okay? Which, okay, they're just saying is equal to Q squared over R squared. And that's equal to the centripetal force, which is MAC, which from before AC is V squared over R. So this is MV squared over R, okay? So this then tells me that,
Well, I'm doing this tomorrow.
what's up?
Can I do this tomorrow in the lecture?
You're going to do this tomorrow in lecture?
Yeah, I read over the content and this looks familiar.
Yeah. So then, yeah, this we're still okay here. This is okay. I like this. This is fine. This part we did here is okay. Yeah.
Yeah.
This is okay. This is delta E. Okay, which says that V. Okay, so then mv squared is equal to q squared over r. All right, and then what we say is for the amount of time, right? The amount of time for something to do a rotation. That was this. It was where was it? 2 pi r over v. From here. 2 pi r over v. Okay, so that is going to go into here. Okay, now I have delta E is equal to negative 2/3 q squared a squared over c to the third, and then this is 2 pi r over v. And then we want to compare this to the kinetic energy, which is going to be divided by 1/2 mv squared. Okay, Jamarcus? Is suicide an option? No, suicide's never an option. Okay. Okay. And then here's the cool thing, is that mv squared was q squared over r. So this goes away. This is q squared over r. Now a bunch of things are going to cancel, which is nice. So the q squared cancels with q squared. R cancels with the r. See how, like I was saying, we couldn't have r? And so this simply becomes negative 4/3. Negative 4/3. Or negative 8/3, I guess, sorry. Negative 8/3 pi. Let's see. That went away. Negative 4, 8 pi thirds. Yeah, okay. And then it's a squared over c to the third over v. And then from this, a, remember, it's v squared over r. So a squared is v to the fourth over r squared. So this is negative 8/3 pi. This is actually very pretty. V to the fourth over r squared, c to the third, and then there's another v from here. This cancels, okay? And so we get it's equal to negative 8/3 pi v cubed over c cubed 1 over r. Very cool. Okay. Wouldn't the r become r squared? Yeah, right here. That's what I did here, I think, right? Did I not do that right? Which r squared? Two pi r. Okay, 1 second. Let me find that. Yeah, I do need one of the r's to go away. Where did I screw this up? 2 pi r over v. Oh, this one right here. No, this is where we got it from, right? Velocity is distance, 2 pi r divided by t. Oh no, in the equation. Where? Here? Numerator of the fraction. Right here? No, this is just r, no, right? Because, again, we had this times t, and t is 2 pi r over v. That just leaves it like that. Oh! Yes! Oh my god, thank you, Jamarcus. Sorry, yeah, this comes up top. This becomes r squared. Thank you. Thank you, Jamarcus. Yes. Oh, you know why that's actually really useful? Because then this cancels out. Yes, thank you, Jamarcus. Okay. Do you see how now you get negative 8/3 pi v cubed over c cubed, okay? And then this is the important thing. Because in the question, I know this is very high-level physics, so I apologize to people watching this who are like, what the fuck's going on? They said it was non-relativistic. Non-relativistic means that the velocity is much less than the speed of light. So we say v over c is much less than 1, okay? So now here, this is going to be much less than 1, goes away. So the change in energy compared to the change in kinetic energy is basically 0. And you're done. Oh my god.
That was good.
Wow. Yeah, there's a lot of concepts in there, man, dude. Like, I thought we could be real basic with just centripetal acceleration and we're done. But then you also needed to throw in Coulomb force stuff. And then you also needed to know, you know, some relativistic type stuff. I don't know. That's a lot. It's a lot for a 7th grader. That's a lot for, honestly, even an undergraduate. I mean, an undergraduate physics person who has gone through classical mechanics and E&M could probably do it. I think this has killed about 2.5k neurons. Yeah, oh no, dude. Oh god. But it's pretty, dude. Stuff like that is why I love physics, because it works out beautifully at the end. You're like, oh wow, it's 0. Nice. Like, love that.
Oh yeah.
Nice.
Love that. Okay, let's give you some coins, Jamarcus. I like that much better than the usual fucking geometry circle theorem questions you give me. Like, those I hate. Did you see the video that that Noise sent us about circle theorems? One sec, I'll pull it up. And then we'll move on to the next question, which I think is yeah, one sec. Where's this? This thing is terrible. Where is it? Yeah. Oh my god, this dude. What? If anyone wants to understand like why I hate circles or circle theorems, how does this guy have 73,000 views? This was painful.
Circle theorems, they're annoying to learn. Pain in the bum, in the bum. Circle theorems, there's no rhyme or reason.
Like, kill this dude! Stop!
Like a boss.
Oh god, dude.
Should love them or
But this is what I'm talking about. Circle theorems. You learn this in geometry. There are all these weird properties of, you know, if a chord goes through a diameter, then technically the angle inscribed is 90. But bless this kid for.
the opposite ones.
I don't know, dude. I feel like this should be against the Geneva Convention for like torture. It's so bad. You know, if you ever want to watch it, Mikasa, there it is. It's really bad. I hate circle theorems, and my hate for circle theorems has never been renewed more than watching that. I was like, Jesus Christ. All right, let's see. Let me turn Streeble mode off. 1 second. Okay, next question. What do we got here? We got Yarbefis. What's up, Yarbefis? When do we raffle? Monday. Monday. Next Monday. I'll do the raffle next Monday. Let me see if he's here, though. I was gonna do one for today, but I'm rolling it into next Monday. That's you still got double credit for all the raffle tickets during last week. Yeah. Which one is what is your Beefy's what is it? What's his Twitch username? Okay. Yes, I love this, Sam. Sam's just like, here's all my questions. Okay, your beef is okay. Dope. Okay, cool. Can you see us? Can you hear us and whatnot? I think you can, right? Which one? Oh, this is cool. This is all Pythagorean theorem stuff. Okay. Let's see. Which one do you need help with? Or just all of them? Oh, you here? He says, okay, cool. Yeah, these are all 30. Yeah, 30, 60, 90s. We love 30, 60, 90s.
Nice.
Love the 30, 60, 90s. Which one? The 2 root 3? This one? You think this one would be nice?
Makes sense. It's not just Pythagorean theorem. Okay. Yeah, so, I mean, all of these are pretty much Pythagorean theorems because as long as you have a 90-degree angle within the triangle, then you can use this rule, which says that, right? A squared plus B squared. And I'll teach you some tricks. So some of this may be like really, common sense. You already know this, but I guarantee there's some tricks here you don't know about. All right?
Yeah, you can use properties of the 30, 60, 90s. Yeah, there's a lot of cool stuff here. So if they give you that one of the angles is 90 at least, and you have all the other sides, you can just use this formula, okay? Where, let's say for this one, we'll start with the hardest one.
That's dope.
Okay, A and B are always going to be what we call the legs, which is basically not the hypotenuse. The hypotenuse, okay, show me another screenshot. Yeah, send me another screenshot. Let me see. You can send it. But just for, yes. Okay, good. Okay, I see what you're saying. Okay, 1 second. This is what you need help understanding. Okay, yeah, totally cool. The shorter leg is always opposite the 30 degree and is always 60. I agree with that. Oh, the 1, 2 square root of 3 stuff. Yeah. Yes. I got you. Yeah, okay. So, yeah, this is a special type of right triangle. Yes, which is the 30, 60, 90. Okay. Yes. Got you. Okay. This is what you're always going to do. I always... Your teacher... This is kind of a weird way. I don't like this. This 2, this, and this. I guess it kind of works. Let's make this the 60. And then this is the 90. Okay. Y'all learn it this way, I guess. You do 2, 1, and then this is the square root of 3, I believe. Is this how you guys learned it, Yarbifus? You learned it this way? Yeah, I don't like this way. This way sucks. I don't know, it's just hard to remember, like 1, 2 square root of 3, because I'm like, wait, which one's the bigger one? I always forget if the square root of 3 is like bigger than 2 or less than 2. I know it's less than 2, but okay. This is the way I like to do it. I always say this is 1, okay? This is always square root of 3 over 2, and then this is always 1/2. This will help you in the long run for when we start doing trig with like sines and cosines and stuff. Remember the triangle like this. So the hypotenuse is 1. The side that is opposite the shorter angle is 1/2, because that's a smaller number than the square root of 3 over 2, which is opposite the bigger angle, which is 60. Okay? The reason why I'm teaching you this way is because later, when we do, for instance, 45, 45, 90s, you're going to learn them this way. You're going to say this is 90, right? And then this is 45. And then this is 45. Okay? This is going to be 1 square root of 2 over 2 square root of 2 over 2. And this will help you. Trust me, this will help you when we start doing, for instance, like what's the sine of 45 degrees? You can be like, okay, cool. This is 45 degrees, opposite over hypotenuse. This is just square root of 2 over 2 over 1. Yeah. And actually, okay. A good thing for your beef is, yeah, you're doing 45, 90s. I have a, I'm trying to think if I did a video. 1 second, let me find the video on this. Okay, yeah. So some of you guys found me from TikTok, obviously. Okay, the reason why I make these TikTok videos is to explain common concepts here that teachers usually always mess up, okay? So what did I do it for? I think it did it for here. Here. Yeah. So if you watch any of these videos, for instance, this will show you easy ways to remember sine, cosine, and tangent for all the instead of doing this unit circle sucks. Like, no one wants to memorize that whole thing. It sucks. It's terrible. But here I teach you that there are only 2 triangles you have to know. This is a less bearded gold. Yeah, this is 2021. This is almost 3 years ago. But yeah, if you watch this, always remember which one is which, because the bigger number will be opposite the bigger angle. So now let's say your teacher asks you to figure out what the cosine of 45 degrees is. The first step is to draw the angle. There are the videos if you guys want them at some point. These are watch these a couple times, and it'll show you how you can basically do anything on the unit circle just knowing 2 triangles, and it's super easy. But in order to do that, these are the 2 triangles you have to know. You have to know that this is 1 1/2 square root of 3 over 2, and you have to know that this is 1 square root of 2 over 2 square root of 2 over 2. Once you know these 2 triangles, you can do any of those special angles on the unit circle. That big nasty thing that they make you. Yeah, you're welcome. Okay. Anyways, so once you know this, okay, let's look at an example question, which is, let's take this one. Let me pull this in real quick. Okay, let me start with a basic one. Let's start with this one, for instance. Okay.
That's an unfortunate name.
What's an unfortunate name?
The special right angle triangle.
The special right angle. Everyone's special.
Always at the back of the bus.
Oh, or on the short bus, dude. I never got to ride the bus actually as a kid. My parents just always drove me to school. But I always wanted to ride the bus. I don't know.
It's very different here. It's a given that you ride the bus.
Or in Norse's case, like, he takes a train, dude. He takes a train and then he rides the bus. Oh, man. Okay. Bus sucks. Doesn't have to mess around. It doesn't have to mess around with the unit circle. Yeah. For real. Okay. Okay. So whenever you see, for instance, a 30, 60, 90 triangle here, you're gonna line it up with this 30, 60, 90 triangle. And then what we're gonna do is use a property of similar triangles to figure out what each one of these variables are. Okay. So what I'm gonna do here is, I know, let's say for instance that y would correspond to 1. You can write that as a fraction. I'm gonna say y over 1. See, hypotenuse of this one, hypotenuse of this one is equal to the short side of this one, which is 5, over the short side of this one, which is 1/2. Okay? Good. Yeah, so y is equal to 10. Yeah. Very easy, right? Okay. And then you can do the same thing with this one, right? Okay. I know y over 1 is equal to x over the square root of 3 over 2. Okay. And y we already figured out, right? Y was 10. So I get 10 over 1 is equal to x over the square root of 3 over 2. And now you have to take this and multiply it over on this side. So this becomes 10 over 1 times the square root of 3 over 2, which is equal to 5 square root of 3, which is equal to x. I feel like that's easier. If you always make the hypotenuse equal to 1, it'll make your life so much easier for doing the unit circle. Yeah. So here, let me show you real quick how that one works. So let's say, for instance, this is just a little bit more of a. Let's say someone wanted you to figure out what the let's say the sine of 210 degrees is. Do you know how to figure this out without memorizing unit circle? It is negative 1/2. Calculator, no. We don't need the calculator. Yeah. So again, the one way to do it would be to memorize this ugly piece of shit. Like, no one wants to do this. This sucks. There's so much. They make kids do. Teachers make kids do that. They make them memorize this, and this is obscene to memorize this many numbers. you just forget it instantly. So I'm gonna show you intuitively how it works. It's actually not that bad. Okay. So what you do, figure out where 210 degrees is on a graph, right? Okay. So if I move this angle over, sorry, right? You gotta copy the whole thing in 5 minutes? Ew. Well, I mean, once you know one of the quadrants, it's not so bad to do the other ones. What is it, like all students take calculus, ASTC or something? But here's what you do. So 210 degrees is probably something like right here. Right? See how this is like 210 degrees? Next thing you do is you draw what's called a reference triangle. You need to find a reference angle. So I take whatever the endpoint is here, and I connect it to this axis. Okay? Don't connect it here. Don't do it. Don't do that. That's wrong. No. Okay. Connect it here. Okay. Make our triangle. All right. Then I need to figure out what this angle is. So here's a good question here, Jarbefus. If I know this is 210, how much is this? What's this angle right here? One sec. It's okay. You let me know if you need help with it. You know how much it is to get to here, right? This is 180 degrees. $30. Yes. So it's 180 to get here. So if you're trying to go the full 210, right? This is going to end up being 30 degrees, okay? Now look what happens here. If this is 30 degrees, this is always going to be 90, right? Whatever line connects here to this, that's going to be 90 degrees. Do you see how we've built our 30, 60, 90 triangle again? Which, from before, let me pull this in. Remember that this is the triangle we memorized, right? So the hypotenuse, which is this side, the longest side, the diagonal, this is equal to 1. The side opposite the 30 degrees, that's equal to 1/2. And then the side opposite the 60 degrees, that's going to be square root of 3/2. And then we have to be a little bit more careful here because we got to put the pluses and the negatives in the right place. So since this is below the x-axis, this is negative. And since this is to the left of the y-axis, this is also negative. Now that you have your triangle, you can figure out all the trig stuff for 210 degrees. So sine of 210, let's remember that. Sine is so katoa, right? So that's opposite over hypotenuse, right? What's the opposite and the hypotenuse for this triangle? Okay, it's alright, He says what? Wah. So, okay, this is your triangle. Oh, maybe you haven't seen this before. Do you know what opposite and adjacent and hypotenuse are for a triangle? Have you done that before? It's okay if you haven't. Like, for instance, if this is my triangle, this is called the opposite. This is the opposite, right? This is the adjacent, and this is called the hypotenuse. So let's look down here, right? So it's like a 5-5-5 triangle. 5 streak, baby. Wow. 5 stream streak. Yeah, congrats, dude. 30 degrees, right? This right here is going to be the opposite. This right here is going to be the hypotenuse. And then this right here is going to be the adjacent. So when I do the opposite over the adjacent, that's going to be negative 1/2. Sorry, opposite of hypotenuse over 1. So that's why the sine of 210 degrees is negative 1/2. Does that make sense? Does that make sense? I can go over it again, Jarbefus, if that didn't make sense right away. I know there's a lot of numbers and shit going on. It's just kind of like... Yes, it does make sense? Okay. All right, so little quiz question here. just to make sure you get it. What would the cosine of 210 degrees be? Remember, cosine is ka, which is adjacent over hypotenuse. Bum, 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 bum. Mm-mm. One sec. He's got it. He's got it. Cool. Mr. Bean's gonna come out and just chill. All right, did we get a jar beefus? Cool. Okay. No, take your time. I'm chilling. Ugh. Radical 3/2. Yes. Negative. Yes. Good. Because the adjacent is this. That's the negative square root of 3/2. And then the hypotenuse is just 1. So this is just equal to negative square root of 3/2. Good. Nice. Good job, dude.
That's dope.
Hope that makes more sense. Yes. Yeah. If you ever, yeah, please always come to me asking questions about this type of stuff with like triangles and whatnot. These are great questions. I love these ones. Because they also apply to a lot of other things that you need to know in other math classes. All right, weekly question goes. What's up, Mikasa?
I have a question that I want to submit as well. Is that okay?
Yes, yeah, just submit it. Do you know where the screenshots channel is? Just throw it in there.
Is it the okay? I'm gonna try. I'm gonna throw it in the office hours chat.
Yeah, you can put.
one.
Yeah, you can put that one there too. That's okay. Just post. You can post. Yeah. If you. Yeah. What's this? Oh, this is
Yeah, it's a little mechanics question.
Okay.
See that?
Let me see if I see it. Office. Oh, it's in the chat. Ah, I see it is. Okay, cool. Yes. Let me do some of the other ones first, and then I'll do this. This is a great question, actually.
Yeah,
I
sure.
like this. Cool. Okay, perfect. All right. Let's see. Who else do we got up on the docket for questions? Where is? Ooh, we got Sam. What's up, Sam? Sam, are you back taking math classes again? I forgot. Do you even have math this year? Yeah, fuck circles, dude. Penn Center, I actually don't hate triangles as long as I can just keep using law of sines and law of cosines to like brute force things. I'm okay with triangles. It's all the weird ass circle theorems. I don't like those because I can't necessarily prove those in my head so easily. Oh wow. Okay, this is cool. 3, 9, 19, 25, 31. 31, 35, 43. Projections, yeah, okay. I like this one. Let's do this one. Prove that it's a right-angled triangle. That's cool. I like this one. Okay. So, let's say they have A is equal to 1, 1, minus 1. B is equal to negative 3, 2, minus 2. And then C is equal to 2, 2, minus 4. Yeah. This is a good one, Sam. And then they say prove triangle ABC. My favorite, Penn Center, it's triangles.
That's dope.
We love triangles. Now, I may not have the most rigorous way to prove this, but what do we know about right triangles, Sam? What's something we know about a right triangle? It's kind of cool. 180 degrees. Well, that's any triangle. So yes. So any triangle, sum of angles is equal to 180 degrees. Yeah, right triangle. Yeah, what's best about a right triangle? Which is kind of what we were doing with Jarbifus's question last time. Right triangle has one angle equal to 90 degrees. Yes. Okay, cool. So this is weird because this is in 3D space, right? You see how we have an x coordinate, a y coordinate, and a z coordinate? So if I were to graph this, right, this is actually going to end up looking like kind of weird, right? This is x, y, z, right? 1, 1, minus 1 is like down here. That's like A. Minus 3, 2, minus 2. That's like B down here. And then C is 2, 2, minus 4. Okay, so like C is like down here. So this is, yeah, this is like our, it's our space of triangles. Looks something like this. Okay. Multiply and add them. Yeah, no, it's close. So what you want to do is we want to figure out what the angle is in between, for instance, these points. Okay. And the way to do that is to first convert each one of these legs into what's called like a vector. So you do have to like kind of subtract and stuff. So if I wanted to figure out, for instance, the angle here, let's find angle A, okay? I need to know what the vector AC is equal to and what the vector AB is equal to, okay? Because that'll tell me what these things are as vectors. Yes. And then from that, I can then take the dot product of these two things. So let's call this, for instance, like vector 1. Let's call this vector 2. Then V1 dotted with V2, which is called the dot product, is the same thing as the magnitude of V1 times the magnitude of V2 times the cosine of the angle in between. And if this angle in between is 90, okay, which means it's a right triangle. So, like, if theta is equal to 90, cosine of... no, sorry, this is... Wait. Do I have this wrong? Yeah, cosine of 90 is equal to 0. Yeah. So, if... right? If this is 0... then the dot product between these two angles, the dot product between these two vectors needs to be 0, is what we say. This is the proof of it per se. If V1, we say it's perpendicular to V2. Does that make sense, Sam, so far? Okay, cool. All right. Do you know how to figure out AC? You know how to figure out how I represent the vector? Vector, it can be thought of as like the directions or like in instructions for like, how do I get from point A to point C? Right? Which way do I got to go? So AC is going to equal like point C minus point A. So if I take the coordinate of C and I subtract it from the coordinate of A, that'll tell me how to go from A to C, which is what this vector V1 is going to be. So in this case, it's going to be 2, 2, minus 4 subtracted from 1, comma 1, comma minus 1. All right? Which, again, you do these component by component. So I do this minus this. So 2 minus 1 is 1. 2 minus 1 is 1. Negative 4 minus minus 1 is going to be minus 3. Right? Because minus minus is plus 1. So minus 4 plus 1 is negative 3. Okay. So this is equal to AC. And then if I want AB, again, that's B minus A. So that's going to be minus 3, comma 2, comma minus 2, minus 1, comma 1, comma minus 1. All right? So that's going to equal to negative 4, 1, minus 1. Okay, cool. All right, so then this is, I think we called this one vector 2. This is V2. This is V1. When you do this, you're kind of taking this triangle and you're taking like this point A, for instance, and you're shifting it to the origin. You're putting it in the origin. And you're like, okay, cool. What does this look like? We're like shifting the whole triangle over, but the angles should be the same. Like whatever the angle is between this part, if the triangle shifted to the origin, it's the same as this angle here. All right. Now what we do is we take the dot product between these two vectors, okay? So I do V1 dotted with V2, which is going to be, I should really put these as brackets. Sorry, these should be the caret braces because now they're vectors. This is 1, comma, minus 3, dotted with minus 4, comma 1, comma minus 1. And when we do that, we look at each component, we multiply them together, and then we add up all the multiplications of each. So I'm going to do these two together. So I'm going to do 1 times negative 4. Right, this is a dot, not a minus. Plus, and then I'm going to do 1 times 1. And then I'm going to do plus negative 3 times negative 1. Okay? This gets me negative 4. This gets me 1. This gets me 3. If I add them all up, that ends up giving me 0. Okay? Which tells me that V1 and V2, so those legs of the triangle, have to be perpendicular to each other. Which means that it's 90 degrees. Oh, you don't have to screenshot all of it. Don't worry. I'll save it as a because I realized I started getting bigger. I'll save it for a page for you. But yeah, basically what we show here is then, okay, cool. So the angle, right? We can say angle BAC is equal to 90 degrees because of all this. And I think that's enough to say it's a right triangle. I think technically, I don't know if you have to say anything else. I mean, technically you could also do the same thing to calculate this angle, and you could show that those angles add up to another 90, which gets you to the 180. But I think this is sufficient. I think if you just show one of the angles is 90, you're okay. But then, yeah, this is where this all comes from. Yeah, don't worry. I will save it for you. So here, let me save it. Yeah, if any of you guys ever want, like, the work we did so that you can go back and put it on your homework and stuff, I will do that for you. There you go. And, yeah, that's how we do that one. What's up, Minion? Yeah, tell me. You should be able to read that, hopefully. Cool. Nice job, Sam. Points go to Sam. What math class are you in, Sam? That looks almost like vector, like a little multivariable calculus, honestly. I forget if I did that in calculus. In like high school calculus. Where do we put this? Weekly question. Nice. Linear algebra, yeah. It looks like a very fun class! Penn Center, wait, you teach linear algebra, don't you, man? Isn't that like your thing? You love linear algebra. I used to hate linear algebra. I've slowly learned to love it. Yeah, it's a lot of stuff for multivariable. Yeah, yeah, a lot of dot products, cross products. Mingo says I'm doing a kangaroo contest again. Tank, what are the kangaroo contests? You want to post a screenshot of your questions, Minion, so we can do them? Help you out. Help is free. Free today. All right, let's see. Next one. Nick. Are you in the stage? Nick, where you at, stage? Nick? Where you at, dog? Wow. This is kind of a mess. This is an absolute mess. Here. Okay, cool. All right. Trying to think which one I want to do first with you. Yeah, this is easy. Well, maybe it's easy. Kitchener you want, or pick whichever you want. Okay, that's cool. Yeah, let's do it. I'm gonna do this one. This one looks cool. Because this actually has some unique things to it. Okay. So let's say we have, what is this? Oh, why is my pen so big? Go back. Okay, there we go. 1 over x squared minus 4, comma, 1 over x minus 2. And we need to prove that this goes to 1 plus 2x over x. Okay. Cool thing I like to notice here, all right, just right off the bat, this looks like a special rule, which we call the difference of squares. Which says, if I have, for instance, a squared minus b squared, this is going to be equal to a plus b times a minus b. Yeah, it's okay. Well, this will teach you something. I mean, and everyone else in the stream should learn from this. This is a very important thing. So when I see this looks like, oh, something squared minus something squared. Or more so, that this looks like 1 over x squared minus 2 squared. Okay? 1 over x squared is the same thing as 1 over x, all of that squared. Because that's 1 squared over x squared, which is just 1 over x squared. You don't believe in the MT coins? Why not? They're easy, Minion. What do you mean you don't believe them? Yeah, okay. So this, which is the same as this, is going to end up being 1 over x minus 2 times 1 over x plus 2. Because again, right? It's this squared, this squared. Well, here, let me put colors on it. Sometimes the colors help. We appreciate Gold for doing this. What do you mean earning 10k more points than everyone? That's just because he had a stockpile. The first week, this is what, Minion, this is why the first week is the first week. This is why it's called orientation, because everyone's going to start at the same page after this. But I want people to get a feel for how this works. Yeah. Okay. So, this, right, which is this, is going to turn into this. Yeah, Minion, don't worry about what the points are right now. I mean, there is a prize. I'm giving out still $100 and shit to people for doing well this week, but it's to make everything fair for going further. Okay. So that's what happens. This right here turns into this, which is this. And now, lo and behold, look at this. We got the same thing on the top and bottom. Goodbye. So now we're left with 1 over x plus 2. Oh, thank you. I appreciate that, Taco. That's great. And now if we want to combine these, okay, this is combining two fractions. Because 2, I can also write as 2 over 1. And now if I want them to have the same common denominator, right, I'm going to multiply this by x, multiply this by x. So now I have 1 over x plus 2x over x, which is equal to 1 plus 2x over x, which I think, yeah, that's what we were trying to prove, right? 1 over 2x plus x. Yeah, so there you go. That's it. That's the answer. Congratulations. Good job.
That's dope.
That's a cool one. Yo, Pensender, when are you doing your 100 tough as fuck integrals stream? I want to be there for that. I think I submitted one. I gave you a tough integral that I think one of the kids I was teaching, like, he has the most like nightmare difficult calculus instructor. Yeah. Yeah, your 100 really difficult integrals. Don't you have one of those? What were you gonna do? I'm trying to remember. It's in your where was it? It was in the elements, I thought, wasn't it? Bonus stream discussion. I think I had it somewhere. Where was it? Ooh, okay. 8 a.m. Yes. Okay, dope. Yeah. That's what it is. Okay, cool. Yeah, so for those who don't know, here, shout out to Pen Center. Pen Center's another awesome math streamer who does lots of cool tutorials. You did like what the Ocarina of Time. He does speed runs and stuff with video games as well. We had a great AMA podcast on Friday. I really enjoyed that one, Pen Center. That really set the mood for my weekend. I love that. But yeah, check out his stream as well. He's going to be doing a bonus stream, yeah, it looks like on February 10th, where he's going to go through 100 really difficult integrals. I think he's just going to like blast through a bunch of them. I'm trying to remember where there was some channel that had the ones that had been discussed. I was trying to figure out where it was. Maybe it was the sub-only chat. I'm trying to remember where it was. But yeah. I'm excited for that stream. That's going to be a fun stream. All right, let's see. Teacup. Yours is next, yeah? You're going to post a PDF soon. Okay, go. Yeah, please. Yeah. Post a PDF. And then maybe I'll show some of them on my stream if we got time. Or you know what I could do, Pen Center? I can make that a bonus challenge for the tournament. Have some of the students try to see if they can do the really difficult ones. Okay, let's see. What's up, Teacup? Are you here, Teacup? Teacup. What's up, Unaccessible? You want to say hi? You can come say hi.
Hi.
Hey, what's up? What's up? Determine whether this one converges. Ew. Ew.
Converge you.
Okay. First thing you always got to check. You always got to check if a sub infinity goes to 0. So if the last term goes to 0, which it does, okay? Because if we just plug in infinity here for n, this is 1 minus the square root of 1 minus 1 over infinity squared. This goes to 0. So we get 1 minus the square root of 1, which is equal to 0. Cool. Great. That means it doesn't diverge. So it doesn't diverge. Which is kind of a weird thing. So you can't say something necessarily converges, but you can be like, well, it doesn't diverge. It doesn't definitely diverge, but we don't know if it converges either. Okay. The next test I can do for this, it's not alternating because it's always positive. Oh, I screwed up. Did I put 2021? Yeah, my bad. Let me fix that. Sorry. Yes, thank you. I was up at 5 a.m. writing all the rules, so I probably put the wrong year. I'm stuck in the past. Yeah, 2021. Jesus, yeah, no. 2024. There you go. Thank you. Integral test or comparison test? Yeah, right? That's why gold is gold without the third letter. God, yeah. Do I know how to do this integral, though? So, what? This is the integral from 2 to infinity of 1 minus integral from 2 to the infinity of square root of 1 minus 1 over n squared. This isn't anything nice, though, is it? Is this... Oh, wait, is this... square root of 1 plus x squared? No. Is that a trig sub? Yeah, I wonder if that is a trig sub. Is this a trig sub one? It might be a trig sub. One sec. Trig substitution integral. Oh, okay. Yeah, they say write it as a secant. Yeah, this is what I want. Okay, sorry. Well, yeah, square root of x squared minus 1. Yeah. So that's this. Okay. So we're going to make the substitution of... so in this case, a is equal to 1. X is equal to 1 over n. Okay. So I say that x is equal to... X is equal to what? What was this? A sine theta? Which is just x is equal to sine theta. And then, dx is equal to cosine theta, d theta. Okay. So n is equal to 1 over x. Oh, I just don't like this. Okay, whatever. So x now goes from 1 over 2 to 1 over infinity, right? So now I can rewrite this integral. This integral from 1 over 2 to 1 over infinity. And then that's going to be the square root of... how's this work again? Yeah, okay, 1 minus x squared. Which is just, yeah, integral from, and then 1/2 to 1 over infinity, 1 minus sine squared is cosine squared, so cosine. No. I think I'm doing this one wrong. Oh. No, I fucked this up completely. My bad. 1 sec. Give me a second. Sorry. Okay. A is equal to 1. X is equal to 1 over n. That's what this is. Okay. Got it. Okay. And then I say that 1 over n is equal to sine of theta. Okay, cool. Because then this is dn. Dn. Or n is equal to, what is this? This is secant of theta? Cosecant, sorry. So dn is equal, what's the derivative of cosecant? Negative cosecant cotangent? D theta. Okay. So now, when I integrate this, that's the square root of 1 minus sine squared theta. And then it's negative cosecant theta cotangent theta d theta. Which is 1 minus sine squared is cosine squared, so it just becomes cosine. So we have cosine of theta, cosecant of theta, cotangent theta, d theta. Cosecant is 1 over sine. Cotangent is sine of theta. Oh, joy. What's that? Integral of cosine squared theta over sine squared theta d theta, which is integral of cotangent squared of theta. I don't really like where that goes. Ew. Yeah, that's so ew. Like, what even is the integral of cotangent squared? Yeah, what? No! I don't want to do this! Wait. Integral of cotangent squared is what? What is it? It's negative cotangent of x minus x? Okay. Okay. Negative cotangent of x minus x? I don't really want to show why that works. Okay. So this is negative cotangent of theta minus theta, where theta... Oh, but this was in terms of n. Ew. I would use a limit comparison test with 1 over squared. Yes, thank you. Yeah, here, let's do it. Yeah, because this is not working. This trig substitution is ugly as fuck. So, okay, limit comparison test. Yeah, you need it with 1 over n squared. Okay. So I need to prove that, so which I know converges. So prove that 1 minus the square root of 1 minus 1 over n squared is always less than 1 over n squared. So I think I can just do 1 divided by the other, right? That's what I can do. So limit as n approaches infinity of 1 over n squared divided by 1 minus the square root of 1 minus 1 over n squared. What's up, not your friend? Good to see you, dude. All right. I think I want to multiply this by the conjugate. That gets me 1 over n squared plus square root of 1 minus 1 over n squared all over n squared divided by 1 minus 1 plus 1 over n squared. Okay, cool. These goes away. I like that. Oh, and I see n squareds and everything. Oh, this is beautiful, actually. Oh, thank you. Thank you, Zone Ranger. This is really good, actually. Yes. Because then these all cancel. Okay. So now I have the limit as n approaches infinity of 1 plus square root of 1 minus 1 over n squared, which this goes to 0. Wait. Oh, wait. Wait, that goes to 2. wait, what do we do wrong here? One sec. Oh, no, that's okay. Yeah, no, that's okay, which is good. That checks out. Because that means 1 over n squared is bigger than 1 minus the square root of 1 minus 1 over n squared. Cool. And so, yes, since this is 1 over n squared, and then since this is my other function, let's say this one, converges, this converges. Yes, love it. Good. So that's a great one.
That's dope.
Whew. Man, I haven't done the limit comparison test in calculus in a minute. That is a tricky one. Yeah, the hard thing with the limit comparison test is picking the right one to compare it to. And you have to kind of guess. You got to be like, well, does this one converge or does this one diverge? Yeah. Okay. Cool. Yeah, this is a good one. I like this. Teacup, I can explain this one to you later in more detail. This is good. All right, have a good one, dude. Yeah. We should go over an easier one first before I show you, like, this is number 52 in the book. So maybe next time look at like number 5 or something. Cuz this is tricky. No, just do it for next one. Do it for the next time. Yeah, you're okay. I got a lot of questions we got to go through today. Who's next? Medkit Man. What's up, Medkit Man? And then I'm going to do Mikasa's, if Mikasa's here. Dude, what? Why can't I copy this image in? What's up, Medkit? Okay, cool. Dividing polynomials. Yes, this was a fun one. I like this, actually. Okay. There are a couple ways to do this. You can either do polynomial long division or synthetic division. I prefer polynomial long division. Pen Center, do you like synthetic better? Like this goofy ass one like this? 3x squared minus 5x minus 22. I prefer this one. Okay. So the way to do this one, Medkit, is it's the same as regular long division. It's the same general strat, which you may have not remembered from, I don't know when you did this in like 6th grade or something, probably like 5th grade. But what you do is you look at each term and you try to see how many times this would go into this. Okay? So, question here is, how many times can x minus 2 go into 3x squared? I know this looks kind of weird because you think to yourself, x minus 2 can't go into 3x squared. Can't really do that, right? But all you're really looking at is the highest power of here and whatever this is. So really what I'm saying is x multiplied by what gets me close to 3x squared. That's all you really look at. You look at this, and then you look at whatever term you're looking at, and you try to see what do I need to multiply this by in order to get into this. Okay, Medkit? So, if I have x, what should I multiply it by to get to 3x squared? Three, close. How about like 3x? 3x is what you want, right? I want this to be equal to 3x, right? Because x times 3x gets me 3x squared. Good? Okay, cool. Awesome, good. You were right with the 3. The 3 was good, but then you need to match the powers, right? This is x to the 1. This is x to the 2, so I need another x. So this is 3x, all right? Now, once I have that, I'm going to take whatever this thing is, and I'm going to multiply it by both of these, okay? So I'm going to do the 3x times the x. That gets me 3x squared. And then I need to do this one times this one. So that's 3x times negative 2, which is going to give me negative 6x, okay? And now, just like doing long division, you're going to carry the numbers down, okay? So this is going to carry down with this. This goes away. This is 0. And then here we have minus 5x minus 6x. Because technically you're doing this whole thing minus this thing, right? Negative 5x minus 6x. Okay? What does this become? What's negative 5x minus 6x? What's up, Cuber? Good to see you here, dude. A plus, good. Yes, exactly. Minus becomes a plus. So you have negative 5x plus 6x, 1x. Yes. Nice. Good. This is just plus x. Okay, plus 1x. All right. Okay. Great. Okay. Next thing we want to see, right, is how many times, right, does this go into 5x? Okay. So I say x times what gets me, and sorry, it's negative 5x, right? What gets you there? Negative 5. Good. Yeah, cool. All right. I think I'm doing this right. I might be doing this wrong. Or this is what happens after 2 hours of streaming. Wait, do I get this into this? Is that what I do next? Yeah, wait. I take that back. Take that back. Roll back 1 sec. 1 sec. The next thing you do, sorry, you see how much it takes to get into this is what it is. Okay. X minus x going into plus 1x, that's just going to be positive 1x. We did bring down the minus 2. The minus 2 was what was multiplied by this. This gave me the minus 6x, and then we brought down into here. So now I take this and I put it into here. Yeah, x minus 2 goes in 1x. Thank you, Zone Ranger. Yeah, I blanked. I had a blank moment there for a second. Yeah. So this is 1x, right? Yeah. Because then watch what happens here, right? This is 1x minus 2, okay? Pull down the minus 22. And now we subtract these, okay? So 1x, 1x, this is 0, right? And then minus 22 minus 2. We have minus 22 minus 2. That's going to be negative 20, okay? So this, yes, good. This is now your remainder, is what it is. Because this will not go into negative 20. X can't go into something that doesn't have x's in it. Right? Yeah. So the way to write your final answer, and sorry, this isn't 1x, this is times 1. My bad. Ugh. This is 3x plus 1 plus the remainder, which in this case is negative 20. And then you divide it by this. This is over x minus 2. This is like your final answer, which plus minus is the same thing as 3x plus 1 minus 20 over x minus 2. Yeah. That's what it is. Yeah. Does that make sense there, Medkit Man? It's a little tricky. Yes, cool. Awesome. Good job. Whew. I'm realizing, yeah, after like 2 hours, I start forgetting how to even do like basic long division. My brain just gets like kind of fried. I don't know how Zach does those math streams with high level, was it real analysis for 3+ hours? Or you too, Penn Center. You always do like these super long streams. My brain just fries after like 2 hours. I start making dumb mistakes. Can I do yours next? Well, let me see. I think I have a couple others coming up. Maybe the next one after that. Let me see if... What's up, Bob Ross? Cool. Next week? That's good. Well, we'll get to it this week. Don't worry. 1 sec. I gotta think. Sorry. Weekly. And this is also, so an idea here, I don't know if Penn Center, if you're still listening, but an idea I have, this is what I kind of wanted to put out to all the other math streamers, was I can have the students here also get credit on y'all's streams if they ask questions, just to kind of like, spread the viewership and stuff. And I think the way I could do this, I could either have you guys keep track of who asks questions and then give points, but that becomes a burden on your point on your behalf. So I think an easier way would be I tell them they can go to your streams to ask questions, but then they need to clip on Twitch when they did it with you. So they have to like create a clip on your channel, and if they submit the clip, I'll count that as a question as well. It's just an idea, because we obviously have people engaged and wanting to ask questions. It's just there's only so much of me. Eventually, my brain dies. All right, let me see if Mikasa's back. You still on? Mikasa gets back. We'll do theirs. Otherwise, Equity and then Not Your Friend. Yes, I can do yours real quick. Yeah. Well, you are next. You are next, Equity. Technically, Mikasa's next, but I think it's probably a little late for Mikasa. Yeah. Oh, okay. All right, here. Let me do this real quick, Mikasa, and then let's do yours. Okay. Equity, do you know how to do this? Do you know how to multiply two things here? You know how to do like A plus... Well, this is not A plus B's. This is... Kinda? Okay. This is technically called FOIL. I don't like FOIL, so I'm going to show you my way. I like doing this. And then what I do is I do the intersections this way. So here I have 2 times 4. You know what that is? Yeah, the box method. I like the box method. Right? 4 times 5 is 20i. 2 times minus 3. Good. You got it. Yep. Negative 6i. This is the tough one. What happens here? Good. Yes. It's negative 15i squared. And then do you know what I squared is? Negative 1. Good. Yes. Good. So this goes away as negative 1. And then this whole thing becomes positive 15. Okay. So now when you add everything together, you get 23. And then minus 6i and plus 20i is plus 14i. And there you go. And you're done.
That's dope.
Does that make sense, Equity? Yeah. All right, Mikasa, we're doing yours now. We're doing yours. Let me get yours out. I like this. Where is it? Fuck. I thought I had it somewhere. Was getting kind of tired of what I know. Yeah. I got to give you guys like a special role for being my European listeners. Here, yeah, my bad. I got it. Where is? Wait, where is? Where did I have your picture of your question? Oh, here it was. Let me copy. 1 sec. Uploading. There we go. And then here, let me give. Equity's got 2,000. It's uploading. All right, let's see. Loading up. There we go. Okay. Material sciences. Okay. Calculate the magnitude and type of force, tension, or compression acting in each member's... Oh, this is an engineering question, isn't it, Mikasa? Here, you can come up to speaking if you want to talk. Wow.
Yeah, it is.
Okay. What is this? Sorry, what's this V here? You might have to... Because I have to, like, convert from, like, engineering language to, you know, physics language.
How does... I think it's a force.
It's a force?
I think. That's what I'm hoping.
This is definitely a
not too
force.
sure.
This is a force, right? There's...
Yeah.
Okay.
Yeah.
Oh, I think I see this. I think I see what's happening. Okay. This is exerting 2,000 newtons straight down is what they're saying. Okay. And then these are unknown forces. We have to figure out what these forces are. And they're related to this structure. And this is a 30, 60, 90. Wow. It all comes together. Right? This is why, you know, even like, you know, the 8th grade kid asking about like 30, 60, 90 triangles, shit comes up. This is like a college level class probably, right?
Yeah, it is.
It is. Okay. All right. Okay. So there's a force here and a force here, which is going to be, I think, exerted through here then, right? Is that what's going to happen? I feel like...
Wait, is that right? Yeah.
I feel like, so this force, right, which goes straight up, translates into some sort of force in this direction. Right?
Yeah,
it has to.
That's true.
Okay.
Yeah.
And then the cool thing is that there has to be a net force from these two, right? In this direction, which has to equal 0, right?
Yeah.
Okay. Starting to get this. Okay. So VAC, that's this part. This is VAC. Okay. And then this is VBC. So what we know from just conservation of... Not conservation. Just from like the sum of the forces has to be 0, right? I know that the 2,000 pointing down has to be equal to VAC plus VBC, right?
Yeah.
Okay. So system of equations, because we have 2 unknowns in one equation, so we need another equation, right? Which I think has to relate with these, okay? So this is a triangle, right? And if this is our angle, then this is the opposite, right? And then this is the adjacent. And then this is the adjacent, right? And this is opposite. And I need these parts to be equal and opposite, right? So tangent of 60 degrees, right, is equal to opposite VAC over, let's call it like VAB, right? A to B,
Wait,
I think.
are we like resolving horizontally and vertically?
Yes. Yes, exactly.
I
So
see.
AC is like the vertical component here, right? And then AB is this component, right?
Yeah.
And then this is tangent of 30 degrees, right? Is equal to VBC over VBA. But I know that these forces need to be the same, right? They have to cancel each other out.
Yeah.
Equal and opposite.
Equilibrium.
Good. And yeah, and I'm not worrying about like directions here and whatnot. I'm just gonna say this is equal to this. Okay.
Yeah.
Okay, great. So, okay, so VAC is equal to VAB, tangent of 60 degrees, and then VBC is equal to VBA, tangent of 30 degrees. Okay.
Mm-hmm.
Tangent of 60 is square root of 3. And this is where this helps, right? This is the triangle I make everyone remember, right? Let's say this is the 60. This is the 30, right? Square root of 3 over 2, 1/2. You see how tangent of 60 is the opposite over the adjacent? So square root of 3 over 2 over 1/2, that's just square root of 3. And then the tangent of 30 degrees, again, opposite over adjacent, that's 1/2 over square root of 3 over 2, which is equal to 1 over the square root of 3, which is equal to the square root of 3 over 3.
Nice.
Right? You see how that's just like a lot easier to just do in your head? You don't have to fucking
Yeah.
mess with like decimals, like fuck all that. Like just yeah. This is why I teach people this triangle. It's so much easier to do stuff. Okay, cool. I know these are the same thing. Okay, so I can divide this by this, right? And you see how that'll go away if I divide this equation by this equation?
Yeah. Wait. If you divide both equations,
I'm going to divide the whole equation.
VAG
I'm going to do
and
this.
VBA will count.
Yeah, do you see how because VAB and VBA are the same thing technically? So these go away, and then it's this over this, right? So this is equal to, this is just equal to 3, right? Oh, very cool. So this tells me that VAC is equal to 3 VBC, right?
Mm-hmm.
Okay. Now we have a system of equations, right? 200 is equal to 3 VBC plus VBC. VBC is equal to 50. So VAC must be equal to 150. Kilonewtons, I guess, is what we have these in, right?
Yeah. Kilonewtons.
Nice. Okay,
Oh.
cool.
Could you like?
Yeah, it's all right. What were you gonna say?
Oh, yeah. Could you like save that and
Oh,
post
yeah,
it in
yeah.
the chat so I can save that as well?
Oh, for
That'd be much
sure.
appreciated.
For sure. Now, the only problem is, like, this isn't the magnitude and type of force, because if they're asking, I think acting in each of the members of the framework is, so here's the issue. Now, if you're trying to find the tension, wait, aren't they all compressions? Because I think they want to know, like, here, here, and here, right? So here you have, this is a compression, right? This must also be a compression. They're all compressions. Okay.
Yeah.
Okay, so the compression, because we're not done yet, in C, that's equal to, I believe it's this force plus this force, right? Because they're fighting each other horizontally.
Mm-hmm.
So, blah 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 blah. Oh, so I need to know what VAB is, right? I gotta solve for this. So that's twice VAB, which is okay because we have this, right? So that's equal to 2 VAC over the square root of 3. I just moved this over and then multiplied it by 2. So that's 300 over the square root of 3. Okay?
Yeah.
That makes sense how I did that?
Mm-hmm.
Okay. And then, okay. Compression in this one. I know I can get like the This is where like engineering and like physics starts to like starts to kind of like not really be nice to each other, because it's just like, okay, but we want the hypotenuse of this, I believe, right? With the component of this, which is pointing in this direction. I believe.
I think so.
Yeah. How does that work? Oh, okay. Oh, because this part is going to get divided between these two. Do you see that?
Divided. How does that work?
So this 200 kilonewtons, right? Some of it's going to go here and some of it's going to go here.
Oh, equally.
I don't think it's going to spread equally. The X components are going to spread equally. The Y components will not. But that's okay. It's the same triangle that we just built. Kind of. Because, one sec. Oh. No. I think we just take twice of this. Yeah, I think whatever this force is, the tension has to be twice that, right? That the compression has to be twice that. Ugh. Yeah. Yes. Okay. I think. You might have to double check that with whatever your engineering class is. But I think the hardest part is solving this. And then I think the compression in A is twice this hypotenuse, and the compression in B is twice this hypotenuse.
All right.
I think so. So wait. You can tell me if this is correct. Compression in A. I kind of think about it like tension in a rope. Do you remember from this in like probably one of your intro classes, right? Whatever the tension was here has to be the same as the tension here.
Yeah, it does.
Right?
Yeah.
I kind of think the same thing here. If there's a force here, that has to be the same here. But then I think technically the term compression in engineering is just doubling it.
Probably, yeah.
Probably, yeah. You'll have to check that for me. I don't exactly know.
Yeah, I'll check tomorrow with my
Okay.
professor.
Oh, but the nice thing is like, okay, so that's just equal to the square root of these okay. So that's equal to the square root of VAC squared plus VAB squared, right?
Yeah.
Okay.
It gives us some dimensions as well, but I don't know what to do with them
What do you mean dimensions?
in the photo.
It gives you some dimensions and oh, you mean like oh, it gives you the distances.
Yeah.
Oh, I see what you're saying. Yeah, do you need those? I feel like you don't, because we used all the angles is what we did. I feel like you can use the dimensions or the angles, I think. Well,
yeah, I guess you could.
the why you probably need the distances is if you're trying to calculate the moments, right? Which is the torques. Because there is a moment about here, right? Do you see how there's a moment here and then there's a moment here?
That makes sense.
That you need the distance. Because yes, in that case, it's this times this. Oh, that would have been so much easier. Oh, fuck me. Yeah. Do you see what I'm saying? If I just calculated the torques around here, the torque here has to be 0, right? So the 200 times 0.5 has to equal VBC times 2, right?
Yeah.
Which, okay, wait, does that give me the same answer? VBC is equal to 50. Aha, look at that. There's the 50, right? You see that?
Yeah.
And then the other one's going to be 150. Okay, so, okay, that's an easier way to do it. Do the torques. The way I did it is, like, kind of excessive, but I think it's also, I mean, this is my math brain. My math brain just defaults to, oh, sum of forces, And this, again, this is what I went over with Ethan at the very, very beginning of this stream, right? I love how everything connects, right? You know, we have a kid in Belize, right, who's asking some question about, what was it, this, right? This is it's the same concept. So where are you in? You're in London, right? An engineering class in London, right? It's cool. Everything's connected.
Just when you did the talks, was it sine 90?
Yeah, so here's what you do. Yeah. So it's because this is considered the perpendicular distance, you're okay to just use this, right? Because what you want is whenever you're doing torque, right, which is torque is equal to R cross F. The way I like to think about it is it's like R perp times F or R times F perp. So it's either the perpendicular distance to the times the force or the distance times the perpendicular force from here.
Yeah.
So, yeah, it's either this is a force, that's a perpendicular distance, right? Or this is like this is the force, or sorry, this is the distance and then this is the perpendicular force. It's like the amount of this that's pointing in this direction. But it's a lot easier when they just give it to you like this. This is already the perpendicular distance. This is like R perp, and then this is F. Yeah. Okay. But yeah, the compression, I think, is then just doing, I assume you know how to do this. This is just find the hypotenuse, right? From, whatever this is. Yeah, I think it is. What did we say VAB was? Yeah, it's 150 over the square root of 3 squared. Yeah. And then the other one is 50 squared plus oh, it's even uglier. No, what is that one? BBC. Oh, it's 150. Oh, 150 over the square root of 3 squared. Are they the same? No, they're not. Okay, because this has a 50, this has a 150. Okay, I think that's what it is. I think. Here, I'll say both of these for you, Mikasa.
Thank you.
Yeah, let me get that, and then this one.
Yeah, it's just kind of hard to see the talks because in the example at the start of the stream, everything's just in like one beam, so it's easier to visualize.
Exactly. Yeah, this is like a system, is what it is.
Yeah.
Yeah. Is it downloading?
Just take a screen.
Here, I got you. I got you the files. I got the files for you.
Thanks. Appreciate it.
Wait, not that one. Oh wait, it is that one. I just wrote on it. I think I did. I think that has that. Yeah, and then this. It's a big file. But okay, good. Nice. Good job, Mikasa. That was kind of cool. I like that one.
Thank you.
You're very welcome, dude. Yeah, get some sleep, dude.
Will do.
All right. Cheers, mate.
See ya.
All right. Nice. Okay. Sorry. Let me go through. Yeah, don't worry about the watch. I don't know. The watch time bot doesn't really work very well. Let me see. TV Contra says, "Can I ask math questions right now?" Yeah, you can. Yeah, of course. Are you in our Discord? Okay, let me see. Who else had questions? I think. Okay, there's Skrek. There's Not Your Friend, and then there's Minion. Okay, let's do it. 2 hours for. I think this is gonna be the longest stream that we've ever had. Yeah, sorry, Penn Center. We're gonna overtake our. Make it a 3-hour stream. Yeah. Okay. Okay. All right, Not Your Friend. Do you want to come to the stage and talk? Like, here, I'll invite you to speak. You can if you want. It's easier for me to explain things to you over voice. Or you can just type. I don't mind. Can't do daily. There you go. Now you can. You'll message? Okay, that's totally cool. All good. Yeah. Just equity. I'll get your... If you registered, like, today, I have to still process all the registration stuff. But you should be able to do the daily now. Okay. In the... triangle is my favorite. Fuck. In the triangle ABC shown in the figure, the midpoints of the sides AB and AC are D and E, respectively. The line DE meets the... Okay. Show that ADE is that similar? ADE. Oh, I think that means shows they're congruent, right? Yeah, this is a good one. Okay, let me show on the screen. All right. We need to show that this triangle, I guess, is congruent to this triangle. AB and AC. Drawn parallel to BA at F. Okay. Well, okay, do you need a formal geometry proof of this? Do we need to do like formal geometry? Like what class is this for? Not your friend. Good question, first off. Like, do you need a formal proof? Or do you want me to just kind of like go through steps of things? This is like kind of the thing sometimes you have to say. Alright. Angle DEA. Let me get this as a smaller thing. Angle DEA is congruent to angle CEF. And that's by vertical angles. So this angle is equal to this angle, right? AE is equal to EC. That is given. Yes, correct. I agree with that. Yeah. So these are, yeah, AE is equal to, I think we just say equal to EC. And that's given. Okay. Because I'm trying to maybe do side angle side. If I want to prove that this triangle is equal to this triangle, I want to show side angle side. But have you done that? The SAS theorem? BAE ECF. Okay, so you're saying this angle ECF. Alternate angles. Are they alternate? Oh, they are. Oh, wow. Yeah, I didn't even see that. Yeah, you're talking about this. Yeah, okay. Yeah. This is technically a transversal. Yeah, these are alternate interior angles. Now, wait a minute. Do we know that this is parallel to this, though? Oh, it is parallel to BA. Okay, yeah, CF. The line DE produced meets the line through C. I don't like this. This to me confuses me. Meets the line through C. DE produced meets the line through C. Drawn parallel to BA at F. Okay, fine. Okay. It is. Yeah, it's kind of given, I guess. Okay, sure. Okay. Oh, okay. Then we're done. Yeah. Angle. What is it? BAE is equal to angle FCE. Right, and that's, yeah, alternate interior angles. Okay. Yeah, and then you can say that triangle ADE is equal to triangle CFE. Right. And that's actually going to be angle side angle. Angle side angle. Cool. Awesome. Yeah, that's a cool one. I like that. Cool. Join AF and DC. Join AF and DC. Okay, so they want us to do this. Okay. Show that ADCF is a parallelogram and its area is equal to the triangle ABC. Oh. They want to show that this is equal to this? Oh. That's harder. Okay. Well, okay. I already know that AD is parallel to CF. Right? It was kind of like given. I need to prove that AF is parallel to DC, though. Oh! Ooh. This is... No. That's a segment bisector. That makes an angular bisector. Yeah. AD equals CF. Corresponding elements. Yes. Okay, yeah, because these triangles were the same. Yeah. Yeah, so we say triangle ADE is equal to triangle CFE. And that's from before. Part 1, right? Okay, cool. So AD is equal to CF. Corresponding. Is that what we call CPCTC? Corresponding CPCTC? I think that's what it's called. I have to remember my geometry. Yeah. Corresponding parts of congruent triangles are congruent. Okay, cool. We proved that. Last part, we got to prove that these two are parallel and that they're equal. Okay. Well, here's what I already know this, right? I know this is equal to this. So I knew angle AEF is equal to angle DEC. And that's vertical angles, right? Vertical angles. Need to get this part. How are we going to get that? If same opposite sides are equal and a parallel in this parallelogram, that theorem is in my book. Yeah. So we already have these are parallel and equal. That's cool. I need to prove that these sides are parallel and equal as well. That's the only tricky part here. Oh, but we said that these triangles are congruent, right? So this is equal to this, right? So DE equals EF. CPCTC. Okay, so these triangles are congruent, right? So DEC is equal to AEF. And that's by side angle side. What's up, Vibe? Doing good. Doing some geometry. Okay. So this triangle equals this triangle. Cool. How do we prove that parallel, though? So now I know DC equals AF. That's CPCTC. Now I just need to prove they're parallel. Oh, you know how I can do this? Haha, this is kind of cool. These are parallel because this angle equals this angle, right? Yeah. DCE is DC well DCA is equal to FAC. And that's also CTC. And then that tells me right away that DC is parallel to AF. And that's alternate interior angles. Yeah. Does that make sense there? Not your friend? Right? If this angle is equal to this angle, good. Then these two have to be parallel because they're alternate interior angles. Cool. All right. All right, we proved that. This is, well, okay. Last part we have to prove is that the area is equal to the triangle ABC. So they say the area is equal to this. How do you show that? I mean, what I see is that this angle is equal to, it's two of these plus two of these. Which means this, if we can show that this is equal to this plus, if this is equal to this, then we're good, right? If I show this is a half of this, how do I show it's a half, though? What's up, Unaccessible?
That's dope. I went to go shower and my friend just called me.
Okay, that's cool, dude.
Yeah, sorry.
You're good. Sorry, let me put a third thing here. Yeah, what's up, man? You can come up. Man, we're so close here. Yeah, I see it. Yeah. You see how you want this and this to be equal to this because another one of these is the whole area of this. ADC is half of ABC. Correct. Well, how do I show that? How do I show that ADC is half of ABC? And ADC is half of the parallelogram as well. Yes. Yeah, that's the thing. Yeah, how do I show that that's half? I wonder if this has to do with this. Because this is a segment bisector thing. What do they call it? A median. Does a median cut the area of a triangle in half? One second, let's look that up. Yes, here we go. All right. Yeah, this is the rule. So, a median cuts the area of a triangle in half. This is what I talk about, how there's all these weird, like, triangle rules, right? So you say, here's you say, DC is median of ABC. And then that's BD is equal to DA. So ADC is equal to BDC. You say median cuts triangle area in half. And was it ADE plus DEC? Oh, I've already hit the max amount of time on my server, dude. Wow, we hit the 3 hours. One sec. I gotta come back in. I gotta sign back in. These are all the questions we've done. Yeah. No, this is all you this is all you have to say. Not your friend. You just have to say that because this here is a median of this triangle, it cuts this area into half. Okay? Which means twice this is equal to this, but twice this is also the area of this. Just write that out. Yeah. Can you do that? Yeah, I don't want to have to like write out all that. That's just a lot. Here, yeah, cool. Let me do someone else's question real quick. I want to make sure I have enough time for everyone, but hopefully this helps you with part 1 and 2. It's a cool question. I like it. There, I'm gonna save the screenshot for you. And then 1 sec, we got this one as well. We did. This one wasn't too bad. I like geometry. Geometry was actually kind of fun. It's like puzzles. 1 second, let me add that in. Yeah, but good question, dude. I like that. That's cool. All right, let's do it. 1 sec. Patient. I can't hear you on Discord, but it's perfectly fine. Oh, can people not hear me on the Discord? I think they can. Check your audio settings. It's kind of weird with stuff. Okay. Cool. All right. Exploded minion, and then we got Skrek. Oh, you can't load both at the same time? Okay. Well, pick whichever one's easiest. I mean, Discord's quicker. There's no latency, but if you can't hear me, then there's no point. Yeah. You going micless today? Oh, it's okay. We'll figure it out. All right. The diagram shows a quadrilateral divided into 4 smaller quadrilaterals with a common vertex. Blah, 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 blah. Okay. The points... Oh, my God, dude. What? Let's divide the sides of the larger quadrilaterals. TU. 3 equal parts. Sorry, what? Three equal parts? What do you mean 3 equal parts? Oh, my bad. Sorry, I see what they're saying. Sorry, this is my 3 hours of streaming brain. I get it. This divides it into, like, this is equal to this, which is equal to this. I get it. And this divides this into this into this. Okay, and this into this. Okay, I got it. I was confused there for a second. Yeah, does that make sense there, Minion? You see how this side is broken up into 3 separate parts? But they're all equal. And this is just like, it's dividing it into thirds. It's dividing all the lengths into thirds. Okay. This is what I talk about in geometry. There is some weird rule here that I don't remember with sides of quadrilaterals in their areas. So to the Google we go. Jesus, no. Oh, that sucks. I don't want that. Oh my God, sorry, what? We got something nice? Something nice? No. Yeah, this is ugly. I don't want this. This is bad. It's gotta be something like the relation of the sum of the sides or something. Hmm. Yeah, because they are kind of like irregular quadrilaterals. Hmm. Okay. Let's think. Hmm. Mm. What class is this for, Minion, dude? What is this for? What class is this for? I'm just looking something up. Give me a second. Oh, it's for a kangaroo math oh, this is a math contest. Oh, okay. Okay, one sec. I might have a solution here. Just want to see it. Okay, here we go. Okay, let me pull it in. I think I got it. I got it. Let's just see what it is. Maybe we can start to understand it a little bit. The very first 3-hour mark, yes.
That's dope.
Yeah, we have hit 3 hours today. We've been streaming a while. Okay, here we go, dude. This is the solution for it, apparently. Jesus Christ, why? All right, says we know that the area of the triangles is equal when their bases and heights are equal. I agree. So they say the triangle DKC is divided in 3 equal areas. DKC, sorry. DK. They're talking about this. Oh, very cool. Wait, but how do we know that's the height? Do you see what they're saying here? They're saying that, okay, so for instance, if I have a triangle like this, I know that this side is equal to this side, which is equal to this side, right? So, oh, they do all have the same height, right? Oh, very cool. Here, Minion, look at this. This is actually pretty cool, right? Because look at this triangle, like right here, this big triangle, like right here, right? You see how they're all going up to the same point? So all of these triangles, and since they all have the same base and they all have the same height, right? That means they all have the same area. Okay? So these all have the same area, and that's what they end up calling A. And then they do the same thing with here, right? These all have the same lengths, same height. They call this B. They call this C. They call this D. Okay, this is done. This is easy. Okay. And then you know the areas of all these different parts. So this triangle, for instance, has 2 of the A triangles and 2 of the B triangles. And that needs to add up to 18. So you say, oh, cool, look, 2A plus 2B is equal to 18. And then you do the same for the other one, for this one. And now you have a systems of equations. You're going to have 3 equations, 4 unknowns, technically. But you're looking for A plus D. Yeah. So then once you have this, you add these 2 together, which gets you this. A plus C plus D is 14. And then you know B plus C is 8. So that means this part must be equal to 6. Yeah, it doesn't need to be perpendicular. Yeah. It doesn't need to be perpendicular because you're right. So technically, in this case here, right? This is the height, okay? But that's the height for this triangle. It's also the height for this triangle, and it's also the height for this triangle, okay? I don't know what this height is, but I know that their bases are all the same, right? So the base times some height, and the base times some height, and the base times some height, all the bases are the same. So they're all called A, exactly. So this is A. Or here, let me use the right colors, sorry. A. Yeah, right? And then this is B, right? Because these are all the same. This is such a cool solution, actually. I do like this. Man, but that's all I need is that little inspiration there. Right, and then this is C. And then this is D. Does that make sense, Minion? Yeah. And then you write out what the equations are. So, for instance, here, this one, right? This is 2A plus 2B is equal to 18. This one is B plus C is equal to 8. This is 2C plus 2D is equal to 10, right? Add this one and this one. You get 2A plus B plus C plus D is equal to 28. Divide by 2, right? A plus B plus C plus D is equal to 14. And then B plus C, this is equal to 8, which means that A plus D must be equal to 6, which is this. This is A plus D, and you're done. Wow. Super cool question. I really like that one. That's a very cool one. Wow. Yeah, that's pretty crazy. Yeah, here, I'll download this. Well, yeah. Download this one for you. Exploded. It's a super cool question. Yeah, it's sad. Again, once I see the answer for it, then it's okay. But otherwise, I'm kind of racking my brain on that. But okay, I will say something that I've noticed, Minion, that I see on a lot of questions that are similar to this one. Is try to always break things up in terms of triangles that have the same height. So, because I've seen this come up a couple times now. Whenever you have like these things all share a point, but they have the same bases, break them up into triangles, like that, and you know that these all have the same height, even though you don't know what the height is. You just know it's the same. This man suffers to help us. I do suffer, but it's okay. Very cool question. All right, let's see. I think we have like last question of the day. Skrek. What's up, Skrek? Yeah. Let's see where Skrek is. Where you at, Skrek? 4-hour mark? No, we can't go to 4 hours. I have to leave in like the next 20 minutes. I have places to be. All right. Okay. Ladder leans against the wall of the building, 71 inches, angles from the ground. How far is it from the top? Okay, cool. Awesome. This is not a bad question. Got a wall. We got a ladder. We got this is 55 degrees. This is 71 inches. How far from the ground in inches is the top of the ladder? Oh, okay. So they want to know X. And then they want to know Y, which is this. Gold will always be a legend, dude. Yeah, if I have 4 hours. That's a lot. Okay, this is not too bad. Sine of 55 degrees is opposite over hypotenuse. X over 71. So X is equal to 71 sine of 55 degrees. Cosine of 55 degrees is equal to Y over 71. So Y is equal to 71 cosine of 55 degrees, which, if you want to pull up the calculator, not bad. 71 sine of 55 is that. Oh, we got to put ourselves in degree mode. Don't forget. It's like we can't have negative distance. No. Okay, cool. So that's 58. So 58.16 from ground. And then 40.72 from base. Nice. Good job, Scrap. All right. Cool. All right. Here's Skrex. Good. Let's give him points. Skrek. To 1,000. Then I need to make a command to just give this. Okay, awesome. All right. Thank you, everyone, for coming to Office Hours today. World record stream. Really appreciate everyone asking their questions. Hope you guys learned something by watching. Huge thank you to our top subscribers there. We got Sam Obama, Sensation. Sensation with the donations, dude.
That's dope.
Love you, Sensation, dude. You're on the telly. Yes, good stream. Awesome. Thanks, Sam. Yeah. Cool. Next stream will be an hour later. That's going to be at 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. If you want to ever know when our streams are, you can just always do this, Discord. That will have it. And then you can always get the schedule like this. Obama, mama, man, yeah. World record, super. Yeah. I got 1.5k points from this stream. Yeah. Yeah. So I mean, that's how the tournament works. Watch the stream, learn. You'll get points. Ask questions, you get even more points. If you already asked a question this week, you can't get MT coins again, but you can always get bond coins. So, you know, if you want to work towards the tiers to get the gift cards and stuff, ask questions. If we have people in the stream, if we don't have anyone in the stream that hasn't gotten their question credit yet, I'll go through yours as well. So, great. Okay, what's up, Obama? What's up? What's up? What's up? What's up? What do you want to say, Obama? Real quick before I go. I'm tired. We've been streaming for almost 3 hours and 15 minutes. Nothing? Ah! Oh my god. Bob. All right, let me see. Are any of the other math streamers streaming? So yeah, if you guys ever want more help with math, we have an awesome collective of math streamers that stream. They're their usernames and stuff. They're really cool. Also, if you raid another channel, I think you get more channel points, right? Is that correct? So if you stick around for the raid and you go to the next one, oh, but there's nobody streaming. What is Science doing, dude? What is he doing? Oh, he's learning about ants. No, whatever. I'm gonna raid this guy. He's funny. Okay, well, I'll still give you guys credit for at least raiding. So here we go. Here, let's send the raid in. All right, these are some kooky people. I think they're pretty fun. They study ants or something, and they have like a science stream with tons of people in it. So say hi to them. Tell them Dr. Gold sent you. Maybe they'll say hi to me at some point. All right. Otherwise, I will see you guys tomorrow. Peace out. Enjoy the rest of your Monday.